Yeah. So, Bhattacharya sir, shall I start the session, sir? Bhattacharya sir. Yeah, I was both there. Yeah.
Yeah, morning. Back again.
Yes, sir. Thank you, sir. Thank you for joining with us. Uh, so now today we have the first session of this FDP, online FDP, Civil Engineering Materials and Techniques for Sustainable Development. So now with us we have our Professor Viswajit Bhattacharya sir, Emeritus Professor from IIT Delhi. So briefly I will give the biodata of the sir. Then after that sir will uh, start his expert lecture with the PPT presentation. So Viswajit Bhattacharya sir is Emeritus Professor at the Department of Civil Engineering, IIT Delhi, and he obtained BTech Honors degree from IIT Kharagpur. Then after that, MTech and PhD degree from IIT Delhi. After that, worked for Majors Gammon India for 2 years after the BTech. Then he is nominated fellow of Indian Association of Structural Engineers and member of several professional bodies such as ICI, ICJ, like that. He was involved with academic activities with several international industries, namely EPFL, Switzerland, University of Dundee, UK, etc. Also, University of Dresden, Germany, and Catholic University at Leuven, Belgium. It is very great honor to us to have Professor Bhattacharya sir with us. He is involved with industry as consultant, also in training, uh, and his students are working in so many industries. Dr. Bhattacharya has supervised more than 30 PhD theses. Just I am telling till today, and three are ongoing. And if you take the master's degrees, MTech 190 already completed, and some are going on. Then he published more than 180 papers in reputed journals and international conferences. He was active in several national committees involving DST, CBRI, NCCBM, Dr. Fixit Laboratories, BIS, etc. Um, and a bio sketch of Professor Bhattacharya titled A Teacher and a Research Worker under the Future People is available in August 2012 issue of ICJ, Indian Concrete Journal, and also under title Gems of Structural Engineering in SCFI. So he is having so many awards and achievements. A recipient of ICI Lifetime Achievement Award North in 2012. He had acted as a member of editorial board of Magazine of Concrete Research and International Journal of 3 Hours, and like that so many journals. He's in the editorial board membership, and he was guest editor of ICJ Journal January 2015 issue on concrete research, and also he is the guest editor in the 2019 volume also. So it is very proud and great honor for us to have Professor Vijit Bhattacharya, Emeritus Professor of IIT Delhi, with us, and he is going to share the topic with us, multifunctional concrete elements for sustainability. So I am handovering this session to sir. Sir, please
Thank you,
carry on.
Dr. Prasad. Thank you very much. You can hear me?
Yes, sir. Yes, sir. We can hear you,
Okay.
sir.
And my screen has to be shared, so I'm just uh, sharing my screen,
Yes, sir.
and you can see my screen now.
Yes, sir. It is coming.
Okay. Okay. So I think I'll go ahead. Thank you very much. So I'll start with it straight away. Just yes,
Yes, sir.
right. It's coming. I hope.
Yes, sir. It is visible and audible also,
Okay,
sir.
just one minute, one more minute. Uh, I need a minute or so because I'm not sure whether it's charging. Otherwise, it will stop in between. So I don't want that. Mm,
Yes, sir.
Yes, I think it's fine now. And just one
Yes.
minute, I'll get out of this and check again. because if it is not charging, then I'll have a little bit of trouble. I will stop in between. Not really, it is not charging at the moment. Just a minute, I'll take.
Yes, yes, sir. No problem, sir.
This is charging, is fine.
But actually, you may take 45 to 50 minutes talk, then you may take small break, then you continue with the discussion also, sir, because it is a 2 hour session.
Yeah, no
Yes, sir.
problem. Don't worry.
Yes, sir.
Okay. This is problematic. Okay, doesn't matter. Let's start. All right. So, good morning, everyone. All listener, whoever are there. And what I'm going to talk about first, of course, I'll talk about little bit about the sustainability issue itself, and then go to uh, multifunctional concrete, because that's what actually is important for in today's context. In today's context, it's very important that we talk about multifunctional uh, concrete, which can serve a lot of purpose. I mean, it's not the concrete alone, but then other materials are also there. So if you look at issues of sustainability, global population is increasing and consumptions are also increasing very fast. And if you see the World Resource Institute, well, last 15 years, well, you can say last 30 years, because this statement is a little bit old, because Resource Institute data is a bit old. Never mind. Production of waste are increasing in spite of increasing the efficiencies. And this is what is alarming. So 2008 Living Planet report gave us the idea that we are consuming more than 20% more of the resources than Earth can produce in a given year. So that's, this is of course the kind of a schematic projected growth of population, and if you see it, world population, if it is growing in the same rate, then it would grow somewhere there. But if you control it, it would go reduce down. One of the major one is Asia, right? And then the Africa. The others more or less stabilized, including somewhat in the Latin America, I mean the South America. It is not increasing that fast because their population density is much lower. So, first of all, we must define two things. Since it's on sustainability, so I'm talking a little bit more on sustainability at the moment. First, we should talk about eco-footprint. And eco-footprint is defined as ecological footprint is of consumption. It is related to consumption. Ecological footprint of consumption, and it is defined as the resource consumed annually, totally, and per unit yield per hectare. So whatever resource you are producing, in fact, there's a way to, we shall see later on, resource consumed and annual yield per hectare. So that is what is eco footprint. Now, when you have waste, so this is for all that you consume, everything. We will see that we put them together. For waste, of course, estimated waste generated and absorptive capacity per hectare. So if you generate waste, how much is the amount you can actually absorb per hectare? So that's what it is. So ecological footprint is basically related to what you consume and generate waste. So ecological footprint of resources consumed. Of course, human beings consume food, that's the fundamental. And then, of course, there are a lot of other things, the industrial goods and so on. So, and in the process, you generate waste. We'll see that. So there are three components in it actually. Ecological footprint of production, if you have imported something and exported as a nation. So you can calculate out the ecological footprint of any of consumption for any nation or any area or whatever it is. The other one is the biocapacity. So ecological footprint is this: production, import minus export. You might have exported something. Biocapacity is what is the capacity of your nation or the space or area that you are talking about on the surface of the earth. So global biocapacity, if you look at it, we define in terms of global, in some sort of way to define this, we'll see that. So imports, exports, consumption, and indirect demand of the biocapacity, because if you are emitting carbon dioxide or anything, then you need some space for this to absorb. Carbon dioxide emissions or production, you need space. So that's the capacity. So capacity is what you can produce, it's possible for you to produce, and what you can actually absorb, waste you can absorb. Carbon dioxide is one of those wastes. Biocapacity for a single land type is calculated in this manner. A is the area, yield factor, area, yield factor, and equivalent, because different things will have different capacity. And this is actually a term related to, because the production changes every year, right? So A is the area of a given land use type within the country. And these are the expressed in terms of what is called global hectare. Area, you can say national hectare. Now, all type of land use will not be same. So a yield factor, again, basically is how much relative yield you have. So world hectares divided by national hectares. So that's yield factor given for the given use type. What is the world average per unit, right? So this is a time related thing, IUIF, yield factor for a given land use type for that year, and doesn't have a unit because it keeps on changing. Every year you don't produce same thing. Every year you don't produce, the production capacity increases, may increase, which has happened actually with industrialization of agriculture and things like that. Earlier, fertilizers and all, they have changed. Green revolution and all that have changed. So therefore, one has to look into that. And equivalence factor for given type of land use. Again, global hectare divided by world hectares. So that is related to equivalent factor, right? So if you see this accounting, this is accounting country-wise. Two aspects are there. This I'll come to a little bit later on. First, let us understand the countries themselves. I have taken only the peak, maximum and the minimum type. So low income is Afghanistan at that point of time, 2019. And per capita gross domestic product is somewhere there, annual, of course. And there's something called Human Development Index, which shows the social, status, in the sense that education, health, and all those things are taken care of. There's even stuff developed largely by Professor Amartya Sen and Makbul Haq, for which, in fact, this is the one which is one of the contribution for which he got his Nobel Prize as well, and even recognizes this. One of the highest is Norway. Lowest is Niger in Africa, low income, and this is the high income. Bangladesh is also somewhere there, Pakistan, low and middle, Sri Lanka, India, low and middle, and all that, and population is here. So these are the kind of thing. And you can see that our Human Development Index is somewhere around 64 for us, Sri Lanka is 77, and so on. So that shows the general state of population. Okay, now eco footprint of consumption, cropland, Afghanistan, or any country for that matter, if you look at it. Grazing land, forest product, built up areas, this is there. So totally is given how much is your ecological footprint of consumption. Right? So that by this formula which we just looked into, so one can actually do this calculation, how much you are producing, consuming, and how much you are importing minus what you are exporting. So, related to that, but it's a ratio, as you can see, and therefore less than 1. So ecological footprint, if you see, it was somewhere here. Ecological footprint was somewhere here. Yield per hectare and resource consumed, and yield. So the Y annual, so it's looked at annual, both are annual figures, consumed and yield, and total area per unit area, and therefore this is also expressed in area terms because hectare, it's a global hectare and all that. So estimated waste generation both for this. So therefore it's a kind of ratio. And if I go back to what I was just talking about right now. Our total ecological footprint, one can calculate out to be 1.2. 1.2, right? 1.2. And any other countries is like that. But I think I like to go a little bit to this country, Norway 5.5, and Niger 1.7 and 0.7 and so on. So this is your ecological footprint and biocapacity. Details one can look into, but I'm just introducing this aspect as well because this is important. Biocapacity, what is your capacity? And capacity wise, if you see, again, the same formulae that I've talked about, cropland, 0.2, grazing, etc., forest product, and taking everything with their equivalent factor, etc., using the formula, you get India 0.4. So number of country required, therefore, for India is 2.7. So we should require around 2.7 times the area that we have. And Afghanistan 1.7, Norway 0.8. So this is what it is. So I don't think I'll go too much into it further. Now, ecological footprint biocapacity is not improving. That's the point that I'd like to make. Ecological footprint, your consumption is increasing, population is growing, and you are producing more of industrial product and a lot of carbon dioxide. So area required to absorb that carbon dioxide through plants. That is also required, is higher, and as a result, this is increasing. And what are the things? Okay, grazing land, right? Number of earths available and demanded. So this is what it is. So with time, you can see that this carbon is one of the major things. So grazing land, it is more or less same. Forest product, built up land, it's increasing. You need more. Demand is more. The number of earths is on one side, and this of course, and this is the number of earth. But for the carbon, we need a lot more space because we got to absorb that through forests or greeneries or whatever it is. Because it's only that which can absorb this carbon dioxide at the moment, till a technology comes for carbon sequestration. At the moment, this is the one. We need space to handle this waste. And if you see this carbon dioxide emission is tons per kilometer square per year, right? And this is population density. So there is some sort of relationship. The towers are here and towers are here. So here the towers. So this is there. Okay, so this is what it is. And carbon cycle, if I look at it, two things are important. Fossil fuel burning, that's the one which generates major portion, 5.3, and next one is cement production. Now, why cement production is quite high? Well, calcium carbonate you burn down, that's fine, that we know actually, and you calcine it to get calcium oxide and carbon dioxide, that we know. But more importantly, the amount of cement we consume is next to water, or rather concrete that you use is next to water per person in the globe. Therefore, rock carbonates and fossil fuel rock carbonates contribute. It's about 1/5. So, 10% or so, 7-8% basically, 0.1 out of 0.53. But some of them are taken by the land. Land use changes, again produces carbon dioxide. So some balancing up here. Ocean also can take some. So all this are there. But the issue is carbon dioxide is a major problem. And considering all that, you need actually, if you go in the same way that we were going in 2010, which still is similar, I believe, you need 3 Earths in 2050. But if you can cut it down, so that's what it would happen. But it has got a secondary effect in terms of global warming, because carbon dioxide is almost like glass. Doesn't allow long wave radiation to pass through it, but actually short wave radiation it allows to come in. So sun's ray can come in, which is solar radiation, is a short wave, solar radiation it allows to pass. But the Earth, terrestrial bodies actually emits long wave radiation, less energy, and they can't pass through glass or carbon dioxide. So therefore the greenhouse effects, global warming and all that. So that's what is causing the problem, mainly how to handle this, all that you are generating. And sustainable means the capacity is 1 Earth. Now, if you need 3 Earths, then there's a problem. Up to 2008, it was actual data available, and beyond that is a scenario. Moderate business as usual, and rapid reduction, then something like this. So sustainability is the capacity to endure or support. That's the definition, and definition given by the committee set up by UN. I suppose his name is there right now somewhere. Somewhere it is given. It is Brundtland Commission in 1987, and that's how they have defined. They have defined sustainability is the capacity to endure or support. Materials shall meet the current needs requirement without compromising with the ability of future generations to meet their needs. That's what we do. So you shouldn't be disturbing the capability of the future generation to handle their own needs. Therefore, materials that you use, also other resources like energy and other water, it should be used with increased efficiency for its production and induction, while reducing impact on human health and environment during the life cycle, up to demolition and disposal of disposal or recycle. So that's what the issue related to sustainability. So all sustainable materials should see that the total energy consumption, etc., material and minimization of the resources used and so on, and should not have impact on human health and environment. So there are three pillars of sustainability. One is environmental, another is social, and third is the economic. So most important, as you can say, the height-wise, I have put it environmental at the top. Social is very important. Economics is also important. And these are the three pillars on which sustainability stands. So using or consuming natural resources, material, energy, water without affecting the need of future generation, and that's Brundtland Commission in 1987. That's what they identified. Now, I just talked about those countries, various countries, and if you see ecological footprints of various countries, and on the the Human Development Index is the one where the social development issues there. It should be this ecological footprint per capita, global hectares per capita. This is 2 is fine. It should not be more than 2. And right, this is fine, and the Human Development Index should be around 0.8. Then it's good. People have, in general, people is in good shape, health, education, and things like that. And that means that you should be less than this, and should be greater than this, and less than this. So it is this quarter. Only Cuba seems to be fitting very close to it. While you see USA is somewhere there, it has got a very high Human Development Index, but then ecological footprint also very high. So therefore, this is the issue. And if you look at Human Development Index and number of arts required, then again, various countries, European Union somewhere there, non-European Union, Europe, Africa, good lot of it. We are somewhere there, 6.64. And number of arts we require, we have seen that we need about 2 point something, so 1.2 divided by 2.7 or some such thing. So we'll be somewhere there. So high Human Development Index, they require more art. So the challenge is here. You want to have high Human Development Index, but at the same time, your ecological footprint should be minimal. This was 2016. These are available in net. So coming to this, how does it relate to our discussion today? Human Development Index is 0.64. Therefore, we need social sustainability. We need more construction facilities. You can't avoid it. Ecological footprint is 2.1. All are in global hectare. And got to do it efficiently. So reduce EFP and use material and system more efficiently. That's how we should be looking at it. So sustainability of construction shall address this issue. That is the most important. And that's why there's so much of talk about using different kind of cements and so on, reduce carbon dioxide in construction. But then there is a much wider than that actually. So basically life cycle energy implications, particularly with reference to building, life cycle carbon dioxide generation, waste plus greenhouse gas, global warming, that's what I mentioned earlier. So contribution to natural resources, depletion other than those used for fossil fuel, that's important, one is to look into. So sustainability performance shall take care of all this, right? So that's what, and materials play a major role in building an infra. The green materials are sustainable and shall have low embodied energy. So what is embodied energy? Embodied energy is related to production plus transportation, energy that's used in production, transportation, and if it is a construction, then erection and those one construction energy will come. For only for material, these two parts are important. So
Sir, any technical problem, sir?
yeah, no, it's come back. It's come back. They come
Yes,
back.
yes, yes.
So uh, production and transportation. That's what I was saying. That's what I was saying. Production and transportation. And while there are some people have been saying that they will be using locally available materials like, let's say, bamboo, mud, and all that. Well, they are definitely green. There is no doubt about that. But where functional concerns are dominant, for example, a hospital building, how do you think you will build it, mud? So conventional engineered material cannot be avoided. That's, you have to take it, that you cannot avoid this. And therefore,
Speaker on करूँगा.
besides constraints of site, landability, etc., therefore you have to use those materials. So therefore, reduction of materials. So therefore, infra and buildings, you have to reduce the materials and production costs. And components must be multifunctional. That's the point that I'm trying to make. That if you use only for the structural purpose a single material, particularly in buildings, it will not be most efficient. It should serve more than one purpose. Load carrying, load bearing. So it should act as a system against all loads. So therefore, for example, our conventional system of design or a conventional system of, you have elements, let's say linear elements like column, then beam, and then you have another column and so on. But then you have infills. This portion will be infills like brick in buildings, brick masonry or something. Now this one's for structures. But if I can make this whole system to work against all loads and both functional, then it becomes multifunctional.
Good morning, sir. Sir, your link, your presentation is not visible to us.
Oh, okay, sorry. I think the sharing has been gone out. I'll go back.
Thank you, sir.
You can always correct. I think sharing has gone out. Sharing. Now it's visible now?
Yes, sir, it is visible now.
Okay, so let's go back.
Your screen is visible. Yes, it's visible. Thank you.
Yeah. So that's what I was saying. So all components must act as a, I was just saying, all components must act together. For example, our conventional, particularly to building, particularly with reference to the building, structural system, if I have linear system like this, a column, a portal, for example, column, beam, and again column, And then what I do, I actually infill them with a third material. And this is supposed to serve many functional purpose. While this is supposed to, the structural system is supposed to serve the function of load carrying the load, keeping the building system safe. But supposing I make this whole thing integral and single, so that it acts against all the loads and also perform other functions, that is climate sensitive, durable, and makes it sustainable. So that's what it should be. Then the system will be more efficient. So multifunctional definitely will be more efficient, will be consuming less material, same element of the building or structures. Of course, it's much less problematic to deal with infra like bridges or dams and things like that. Building is most complex. And then we should look into life cycle problems. So these are the challenges, particularly with the modern building. And obviously, speed of construction and quality is important. Now, again, coming to even bridges, if we can, multifunctionality has got its advantages. There are two, all right? So, should serve as structural system to carry the load, and also if it is part of the pavement system, which at the moment is not there because vibration resistance, wearing coat, and all those are there. It's audible, right? It's audible and visible. It's audible and visible.
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
So our technological processor take material from the earth, manipulate them, and make something out of it, use it, and then dispose it off, demolish, or generate finally as waste. But at the production process also we generate a lot of waste. So when we take, manipulate, etc., we generate waste, and all these have detrimental effects on ecosystem. So this is, and everywhere you consume energy. So here you see, and this actually, at this stage, this is your embodied energy, and then later on, of course, is operational energy if it is in buildings. So engineered material, most efficient handling and optimal use by design and construction of the solution. So that's the point, because there is, title also says technique. So I thought I'll talk something about technique rather than only material. Multifunctional would be there. Now, generally, when I am looking at building, natural condition, if I look at annually or daily, diurnal as we call it, any variation, say temperature will vary like this, winter temperature, summer temperature, or daily 3 p.m. and early 5 a.m. or 4 a.m. So there is perturbation of the climatic conditions. Same thing with the relative humidity. Relative humidity will be maximum here, minimum there, but the curve will only change. So the natural things, it's all periodic, because the sun, it is related to sun-earth relationship. But I can modify this using microclimatic control. That means urban design, settlement, and all that starts from there. And then you do the structural control, the multifunctionality, and then if you want absolute control, then you can have mechanical control. So that's what again is showing, the same one, I'm showing it like that. Therefore, first it starts from microclimatic control or urban. And building is the most complex among the infrastructure, and therefore I'm taking example of that. All others will have much less complicacy. All others will have much less complicacy. All others will have much less complicacy, right? So building will have maximum. Involves simultaneous interaction of civil, structural, mechanical, electrical, IT and architectural concepts, all. So it's not only, if you look at bridge, mainly you have civil work, right? Structural and civil works, little bit of electrical, and may have a little bit of mechanical and all those. So, but while you come to a hospital, as I said, structures might cost only 30%. Urban system is far more complex, and building is a part of that only. And you want to control the microclimatic control you want to have, that starts from there. And therefore, you cannot ignore this. Like this gentleman, Frank Lloyd Wright, an American architect, said the function is more important than aesthetic. Look, he's not a formal architect, but he was the one who thought function was more important. And I think I'll not go too much into this, but this is important. Bounded by geographical boundary, of course, is in any urban area, non-extractive population, they consume only the urban area. They have a mechanical, the urban area has got a mechanical infrastructure facility. High population density, these are characteristics of urban area. And generally have a political status like corporation, municipal board, etc., etc. And sometimes it's a symbol of wealth and lifestyle. And that area, right from that, or if it is even rural area, the generally the microclimatic condition is as natural as it was or it is. Well, urban area is where we are doing modification. And therefore, there the problem is, typically it will look like this. Urban atmosphere, if I say it, there's a urban biosphere, deal with greeneries and all that. Hydrosphere, the groundwater, and peda, and the rocks and things like that, and built-up systems all combined, and that's of course atmosphere at the top. All combined actually forms the urban system. If I see it again, atmosphere here, built environment, lithosphere is the biosphere, and hydrosphere is the water. So if you see this, the city, it gets agricultural, food, etc., water supply from outside, fuel and raw material and power, all from outside. That is the input. And the clean air, and then it modifies the air and generates liquid waste, solid waste. And of course, this is manufactured good is both ways. So that's actually an urban environment is. And that starting from there, actually, planning is very important. Starting from there, you can control the microclimatic features and bring down your consumption, particularly energy consumption. But there is other issue. For example, if the population density is very high, it's not there are concepts of the kind of satellite cities earlier. So you have the main city, the satellite cities from where people will be traveling, and it's still this concept of relatively now there's a tendency, at least in Indian scenario, to concentrate, increase FAR. I think this is a very wrong kind of philosophy to increase FAR. Population density will increase, which actually causes increase in everything. Pollution, vehicular density. Also, the city area is pretty large. It's not that people won't be traveling, even if you increase the population density. And cities like Mumbai or Delhi, they have increased their FAR significantly. And it was one of the reports in recent report showed that that actually Mumbai has lost its greenery by possibly about 60% or something. So that's what it is. GIS journal or some such places, some people have studied. So earlier, urban neighborhood and microclimatic modification in this context. Earlier, in 1925, an urban area was defined like this: neighborhood concept. Today, somehow or other, it is gone. Clarence Perry gave it in America in 1925. And the main thrust was the primary school. And this is the main arterial highway. So according to this concept of neighborhood, everything will be within half a mile. A kindergarten child will walk only, won't have to walk more than 1/4 of a mile radius. And the population within this, in a given neighborhood, will be sustained to one primary school only. But this has all changed. And the cities have started generating anthropogenic heat because we are concentrating annual amount of heat that is generating is something like this. So as population density increases, anthropogenic heat flux, the amount of heat generated by human being tends to increase. Delhi is not there in this one, or neither Mumbai or Chennai, but we have data for Manhattan, Hong Kong, Salt Lake City, in the west, some of this Canada and so on, and Europe as well. So you see that as the population density increases, you tend to increase the heat generation. And this is what I said earlier. This is this is basically rural atmosphere, and this is the urban atmosphere. This is the upper limit, and this is the this is the bottom limit actually. This is the urban surface, subsurface, surface. So there's a difference. Surface you are creating is of this type. So when you talk of sustainability, these issues will all come. So this is called canopy layer. UCL is upper canopy layer. That is the top of all the roofs, if you make an imaginary plane over there. And boundary layer is this top, urban atmosphere boundary layer. So this is what is happening. And urban heat island issue is there. Tokyo temperature has been increasing. More we concentrate, increase the population density, urban temperature is usually higher than surrounding. So you got to control it both with greeneries and control of population density and so on. This is what has been seen, images from NASA. Red spot shows high temperature. Correlation of temperature with greens. So why there are greens, there are less temperature. Where you have construction, you have high temperature. So microclimatic effect is this type. Well, trees, of course, have taken advantage. They bring down the heat. We did a study, although I didn't include anything there here in this one, because I'm talking of multifunctional elements. But I wanted to introduce this. It's 2 hours lecture. I did quite a bit of other things as well. So basically, objective is to reduce energy use, reduce heat fluxes, right, and health risks. So basically, measurement and all that, I think I'm not interested. So mitigation is basically by trees. This is Mexico, 1875, and current, if you see, it is all built-up area. Delhi, 1807, 1930, capital was shifted and construction started. And today's Delhi is something like this. Something like this. So you see, we are creating actually and master plan 2021. Now one has to keep, that's a larger issue, but surely an issue of concern for civil engineers also. Right? Urban issues are dealt with by a lot of people, geography, architecture, urban planners, policymakers, and so on. But this is important issue and we've got to look into it. Strategy to mitigate it: trees and vegetation, green roofs, tree pavement, smart growth. Now we studied actually this. Trees, definitely we studied this, we measured for 1 year temperature in Humayun's tomb in Delhi. I didn't keep that data here. So then this would be the main feature. So trees and vegetation can bring down the Temperature increases the relative humidity, and we could model it. Theoretical models are available using concepts from irrigation, Penman-Montiat's equation and things like that. So one can actually find those. Then, of course, automation, Internet of Things, by reducing unwanted waste. But first, your system should be passive system should be good, whether it's the urban area or the building. Then you can put in those ones which will make it good. Otherwise, it's going to walk out. So, better control and management is possible through this. Better planning, optimal population density, these are the first requirements. And control of energy, many aspects of urban ecosystem, and many other things we should be controlling. So, envelope, I think some of you who have gone through some of my energy efficiency process should have looked into the building envelope. And this is how we define the envelope is this from the envelope boundary. This is in 3D. The features which is there in the facade, that's on the envelope, the wall, and some shades and things like that. And this actually controls membrane that filters out undesirable external environmental influences. You can tell me when to stop, break, and you can have some questions then.
Yes, sir.
So you tell me when to stop, and then I'll have some questions from them, and maybe have a gap of 2 minutes. Right? So, building envelope is supposed to act as a membrane that filters out undesirable external environmental things and allow light to enter for visual comfort, but should not allow heat to enter. That's the function of envelope in tropical climate. So your material system should look into both. Not only it should take structural load, but it should also do this. And if you use in building, there's other interests keeping them aside. Because building consumes, if you see even India as a nation, building consumes majority of the cement. Your construction, volume of construction is much higher. If at least, it's double of possibly the other thing, and for other interests. So materials use envelope major role, and therefore all these features are there, glass area, fenestration, as much as possible. One might, but then I am not looking into that part at the moment. The material, so this is your building, I think I would have shown you sometime. The environmental feature which are there are humidity, air motion, lightning, rain, snowfall, sunlight, and air temperatures, solar radiation. These are all natural. This is man-made. This is man-made. So building interacts with this environment in this manner. Noise is largely man-made, and pollution of all kinds, which are most of our cities are now facing, particularly New Delhi, which is topping in the list according to the newspaper report, right? And that's related to all this. So it interacts. It has to interact with all these features, and you got to take care of it. The issue of heat flow in building is important. I'm not going into details of this. Just I'm telling you, it's the solar radiation, the temperature outside plays a role because conduction, floor, solid wall, etc., etc., and then casual heat gain from appliances and human breathing. Direct sunlight, solar radiation can enter to the windows. So we do model all this, but I think I'll not talk about that. And the important aspect is thermal comfort. Temperature, body temperature should be in an optimal situation. Body gains heat, then it can lose. One of the ways of losing is by sweating, right? So it gains by basic mechanism of heat transfer, and it also generates heat because all the time our heart is working, and therefore body generates heat all the time. Even if you are sleeping, there's some amount of metabolic heat generation, and sweat is the mechanism by which body starts evaporating, lost to evaporation by bringing in moisture at your skin sample. You lose through perspiration. And when temperature outside is low, you start shivering. That generates more heat. So that's related to thermal comfort. Therefore, comfortable against natural and external environment, the space should be temperature, relative humidity, moisture ingress, and condensation. And man-made external and internal agency causing discomfort, for example, noise, right? So all these issues are related to actually sustainability of building. Thermal design, I don't think I'll go details into it, but I'm just saying external variation could be something like this. Thermally efficient building will reduce this. Inefficient building may not do this. So therefore, your material system of the envelope is very important. Otherwise, you'll be somewhere there rather than this. Perturbation will be reduced. This is the zone which is comfortable zone, right? Which is comfortable. Daylight is the other thing. You should allow diffuse light from sky gold to come in, but don't want this direct sunlight. No, you don't want it. And reflected from external buildings. So design of the system should be like that. And if required, then artificial lighting and illumination is might use. So these models I am not talking about and not here. And this is important to know as far as India is concerned. This is our optimistic zone. I might sometime later on also I might come to this slides again or there in the scenario. So this is called hot dry desert climate. Hot dry climate. This is called composite monsoon climate, and you are somewhere there, which is warm humid climate, a lot of rainfall, a lot of humidity, and cold where the humidity is mean temperature is below this and relative humidity is very high. This space. Some part of Northeast is there. Meghalaya, for example, part of Meghalaya, part of Nagaland, Manipur, and of course Arunachal Pradesh and Sikkim. Yeah, this kind of cold temperature. Somewhere here in Nilgiris, Ghats and all those, you have similar situations. But this is where temperature is high, relative humidity is low, and this is, this portion where temperature is also high, humidity is also high. This one is moderate climate, somewhere there. Okay, so temperate climate as we call it. So this is climates. Therefore, challenges reduction of materials and production cost. Demand for large volume of construction that is there because we got to have a lot of infra, social sustainability. And it should be climate sensitive, durable and sustainable, and should have good life cycle plan. Speed of construction and quality is important. And all this you can get through multifunctional system. Just quickly, I'll break for a while. Just after this, so conventional construction, linear elements. That's what I said. Linear element, beam, column, maybe your shear wall, and their on-site construction. Frames carry structural load. Frame carries structural load. External infill forms the envelope and accounts for functional performance, leading to higher cost. That's conventional. And designed for one function, that has been happening. Sometimes not even designed is thumb rule. Put 9-inch or 225 mm brick on the wall, although you may not require it. So building as a case been taken because it's the most complex of infrastructure, and if you take care of this, rest all automatically you'll understand how to take care. Should have lowered embodied energy, durability and aggressive if required in Gulf condition as well. Lower carbon emission for less and efficient material use. Modular design and efficient structural and functional design. That's what it should be. And therefore, you should be able to use issues of sustainability. So, I think I'll stop here for a minute. if you have some questions, I'll answer and then go to my material scenario, concrete as a material for sustainability and multi-dimensional, uh,
Any queries from the audience?
yes.
You can discuss with sir. Till now, whatever sir is presented, you want any discussion, you want any query? Right. Yes.
Any question? Any question? Any question? Yes, any question from anybody? Is there a chat box or something?
Yes, if you have any clarification, you can type in the message also, chat box also. That also sir can see and he will answer.
There's a chat box, right? Yes, there is one. Of course, good morning. Okay, no questions so far. No, I didn't see any. In the chat box, there are no question.
Yes, sir.
Okay. So shall we continue?
Yes, sir. I think better you continue and you
Yeah,
finish.
we'll do that.
Yes, sir.
We'll do that. If there is a question in between, you can write also in the chat box. You can write also in the chat box, right? So you can do that. Let me just check my battery power is working, otherwise that could lead to problem. That could lead to problem. I don't want that. I don't want that to happen. Right? Okay, so let's go back. So, going back, just a minute, let me adjust the power supply business, otherwise I shouldn't again run into trouble. 1 minute I'll take, that it should not close down somewhere in between. Let me see if this is working. This power supply system is not working. No. Okay, no problem. No matter, that's good. It is working and the port is not working properly. Right, so let's go back to our thing as possible. So if you look at concrete, now I'm obviously talking of multifunctional elements and I'm talking of surely for concrete, but it's not concrete alone. Even steel, concrete, composite.
But if any cover comes,
Both would be there. Both would be there. All right, I think it's not working. Doesn't matter. I will manage it. So if you look at concrete as a composite, I can represent it like this. So x direction is binders, and for reduction in carbon, today people are looking at various options because OPC is the one which uses largely calcium carbon, and therefore the carbon dioxide comes from it. So try to reduce, the consumption of OPC, ordinary Portland cement. So there are a lot of binders, like pozzolana has been used right from 1970s. People started researching, and then BGBFS, granulated blast furnace slags, were there for a long time. Now there are other kind of cements which were not really considered earlier, like high belite cement, C2S is more, C3S is less. And then magnesia cement rather than calcium cement, where the mechanism is slightly different. It's carbon dioxide emission is not there actually. So for magnesia based cement, things are quite different. And then you have got other kinds, so many activated uh, slag, activated fly ash, geopolymer, and so many of them. And obviously with lot more advantage of chemical admixture. So these are the binder system. For example, we might have OPC and water, OPC water and some sort of silica fume or something, geopolymer, and there could be more kind of, you know, mm, more kind of binders. The skeleton matrix, the aggregate, which might also include recycled aggregate. This is used quartz 600 mm down, 6 millimeter down is used in a reactive powder concrete. So you can have skeleton matrix of the varieties of kind, and you might have even fiber reinforcement because it's brittle, so reduce down the pseudo-ductility you can introduce. So polypropylene, polyester, they improve, of course, especially in case of pavement, they improve the plastic shrinkage, plastic state performances, while steel fiber is very good for crack arrestation and things like that. So you might use them. Conventional reinforcement, of course, is used on top of this, right? So these are resin hardener. Yes, this is resin hardener, but that's not used alone. But it can be a possibility depending upon situation, and that's the nomenclature. So there are various types of fibers one can use, and then use reinforcement. So, for example, this high performance concrete. I don't think I'll go into this too much. And next, if you look at performance, it's very versatile material. One dimension is moldability and rheology. That means you look at the fresh state properties, no slump at all to viscous fluid like self-compacting concrete. So this also varies. You can actually have a variation in moldability in terms of its performance. In terms of so-called strength, as we understand the load carrying capacity, mass concrete is just somewhere down below to 200 grade reactive powder concrete, compressive strength, and long-term performance can go to service life infinity. You can make it robust or thin, and concrete is versatile. So actually, obviously, for two aspects, it's not as good. So tension and ductility, it can be taken care of by steel in some form, pre-stressed, or any other, pre-stressed or reinforced. And many other polymeric material like Kevlar has been used, for pre-stressing successfully. Obviously, fibers are yet to. The others are the steel reinforcement. Instead of replacing steel reinforcement by FRP or fiber reinforced plastic reinforcement, still I'd say that it is good for distribution steel, not so good for main bars and things like this. So there are issues, but pre-stressing, yes, it has been used successfully many years back. So you see, design, if you look at it, the material system design I'm talking of, your required performance is here. Rheology, service life, and strength. And from your requirement, you can actually design in that three-dimensional, at least three-dimensional, because I put in to show it is good to show in three-dimensional. So you can design depending upon your requirement of strength, requirement of rheological properties, requirement of long-term performance. You can design the material system. You can design the way you like. So that's the advantage of concrete. Is very versatile material. That's what I say. So multifunctional design is possible with concrete system. Mass housing and large-scale construction for economy, optimal multifunctional design and to industrialized construction. Speed of construction and quality is important, so therefore all. And industrialized or specialized material for construction, that's what it is. It is actually possible through offsite or offsite manufacturing, OSM, what we call. Offsite construction is planning, designing, fabricating, transporting, and assembling of building elements for rapid site assembly to a greater degree to finish than in traditional piecemeal on-site construction. So what we are saying is this is better. A range of materials, scales, and system. You can use softwares like BIM, Building Information Modeling, or many other softwares. You can actually, many other of them are likely to come, or they are possibly there. More environments are likely to come. And for manufacture and fabrication and innovation in social and technological. So, offsite outputs are componentized, panelized, or modularized elements. Component size is like linear. Panel means walls, roof, and modular elements means 3D modular, straight away. So for service of structural enclosure and interior partition system, everything. So this can give you this. Offsite construction can give you, right? Can give you multifunctional system easily. So optimization strategy of offsite is to integrate this system and supply chain through research, design, etc., etc. So I don't think I'll go into this. So if you see spectrum of offsite production, modular is the most complete in factory finish. What is modular? 3D, three-dimensional box. Up to 95% and in some cases shipped and assembled as 3D volumetric units that are service or structural units to be joined on site. Now, the moment you make it 3D volumetric and even in 2D, you are actually combining more than one function. Not only the load carrying, but it will have environmental aspects also built in there. For example, thermal, noise, all this can be built in. So component is one which is non-volumetric, then volumetric, then hybrid, and modular building is the extreme. Offsite construction is where sub-elements are constructed remotely, then transferred to and installed on site as distinguished from in situ methods built directly on site. This is the one which will make it actually sustainable, both socially or environmentally. Economy also, provided you have large volume. There are 4 classifications possible: component manufacture and sub-assembly such as door, furniture, etc. But I think again details will be too long. Non-volumetric pre-assembly, those units that do not enclose usable space like wall panels. So this is the first one is component. Second one is non-volumetric, and third is volumetric pre-assembly, those units that enclose usable space like 3D modules. Units that themselves form usable building with only minimal work left to be accomplished on site. That's an extreme case. But many of them are, this is still in research stage for many aspects, but it's possible. So off-site manufacturing, off-site fabrication, these are the terminology used. And this is how it will look like. So your design is here, then manufacturing, followed by transportation, handling and transportation, then goes to the site, and then installation, and then finally the occupancy is found. So this is the cycle. This is the complete cycle. And here you can combine multifunctional. So everything is related to everything. Design. Everyone drives the other one. People, process, and technology all there. Everywhere you need people, process, and technology. And people, process, and technology all over. And therefore they drive, each one drives the other. So this is, for example, planar system. And this is Indian. was taken from Indian sites. Drainage system. That means you have got walls or roof system. This is what it is. So this is a component of a wall. Precast concrete structural and precast concrete structure being assembled finally. Increasing construction efficiency through modular requires examination of construction performance. Every project must consider a number of performance factors including cost, labor, scope, quality, and risk. The financial risk, of course. Documented, of course, construction when we shorter construction schedule, greater degree of predictability, less material waste, reduced carbon emission due to transportation to and from site associated with offsite construction, reduce site disturbances, and finally an increase in safety and security of laborers and trading group. You see, so sustainable construction should look really to this. Modular buildings and modular homes are prefabricated building houses that consist of repeated sections called modules. Section away from the building site, you construct them and then deliver. And installation of the section is completed at on site. So that's what it is. Concrete modular, the high-tech mold with precision. Some diagram is there. Rebar placing. That's what is showing. Rebar placing. This is the mold. And the modular construction mod for mold. The reinforcement is being placed here and is placed. So this is the module. And three-dimensional modules can be placed side by side. Insulation and reinforcement, everything can be put in there. Some of those I'll show you. So this is what is three-dimensional system taken, transported. Somewhere they are cast simultaneously to have monolithic module. You are saving a lot of material because structurally it's all integral. So load will be shared by each one of them. This space you are not leaving out for something else to come and fill in. So structural system is combined and that's being transported. Toward lifting to lifting strength, lifted and transported. Well, this tunnel formwork has been used in India for quite some time now, more than 20 years. At least first building I saw somewhere in 1997 in Bengaluru by L&T. Maybe they were doing it even earlier. The tunnel form construction is also multifunctional construction. What you do is you actually the reinforcement you have put in. This is a tunnel form. Looks like a tunnel. It's like a tunnel. So the wall, slab, they're all together. The wall reinforcement you put in, and then it is cast. The reinforcement is protruding out. Slab will be cast on top of it. The slab reinforcement, and then slab is cast. Then, of course, they are cured at slightly higher temperature so that you can remove the tunnel mold. This has been used in India. And that's what it looks like. That's what it looks like. Hotel building, for example, will be an ideal one to do this, but residential building as well. The Mivan form, the aluminum form, right? They also cast everything together. Therefore, multifunctional possibilities very much. 3D printed concrete forms load-bearing wall and insulation and reinforcement you can put in there. So this is 3D printed concrete. This is a recent development. You can have shapes and you can actually make everything integral. So this is climate zone of India, which I've already talked about, tropical climates here. This is the features. I don't think I'll repeat this. Hot, dry climate and moderate and cold, cloudy and so on. There are various features are given. How do you define them? right? And composite monsoon climate is one, the major central Indian portion where it doesn't fit into either of these, or any one of these. And this also already looked, but the point that I want to make in here. So if you are doing this industrialized construction, you can actually, the wall can be designed to have appropriate value of what you call U value, which is a function of thermal conductivity, the thickness, heat capacity, so U value is function of this heat capacity, the density, specific heat, and thickness again. These are the ones which play important role here. Short wave absorptivity and emissivity is long wave emissivity. This is important of the surfaces. And albedo is a reflected component. Whatever comes in absorbed by surface. And then the steady, this is because the temperature varies, fluctuates with unsteady flow through the wall. One can mathematically model that, but I think I'm not interested in this class related to this. I mean, this discussion related to this. But the properties are important. So we have to see the properties. So you see, rho C, the thermal capacity, density, specific plays a major role in some of the climates, especially if you want, because the heat that is coming onto the one surface of the wall will enter into the building sometime later. Temperature increase at 3 p.m., let us say outside is maximum. The heat flow will be somewhat later, but if you have proper kind of design, then it might enter. Supposing it enters, it is becoming cool, something like 12, 13 hours later, early in the morning, then it's good. But if it enters around 12 p.m. and in the west-facing wall, which means that around 4 p.m. it will have maximum, 4, 5 p.m. it will have maximum temperature, then supposing 7 hours, 6, 7 hours is the time lag, this TL stands for time lag, after which the heat will come. You can see the difference between these two. This is called time lag. And if this is small, then heat will come during your, useful time. And if it comes later, so these are issues actually you can design the system. This is typical Delhi, May and August temperature. Internal temperature, unconditioned, naturally conditioned space. External mean and internal mean is somewhat up. You can calculate this out, and this also differs. There's a difference. So one can calculate this out. Now, thermal comfort I'm not going to talk about, which I did, and this also is not important anymore. And decision variables are envelope I should design variables, orientation, shape, fenestration, shading device, and all those. U value is important for conditioned building, for naturally conditioned building. This is also important. So the point that I'm trying to make is not related to this, but these are the important properties. Hollow core slab, for example, it's by the whole design system. It's a prefabricated system, precast thing. Slab panels are cast on a long line method. So you have a long bed. Many of them might be there, and the slab you cast, there's a pretension wire that first you stress it, which goes into the holes actually, right? And I mean, pretension are not on the holes. Then the holes are also left, and this prestress wire is actually you pull it, and then this is cast with holes, hollow core. So the heat flow is reduced because this is hollow air gap there, and this reduces the heat flow. AU of the H will play a role because they are acting, in series. So 1 over U, this is the formula given. I again not going to details of this. Autoclaved aerated concrete, somewhat they are also used for structural purpose, right? So they can also serve sometime multifunctional depending upon types of buildings. So foam concrete and autoclaved concrete, chemical expansion agent like aluminum powder, then autoclaving and curing, but their embodied energy is to be seen. because this will need a lot of energy in the beginning. Foaming agent, there are various kind of foaming agent, and this non-autoclave is this, because there are organic ones, right? So you add them, the foam, or you insert the foam straight away into the concrete or mortar system itself, and that's what it is. So it's lightweight, easy to handle, can be installed and done as masonry units. This is what it is. This is low-rise building one can look into. They two combine both load-bearing aspect and although it's not industrialized, to a great extent, much less industrialized, I'll say. But ASC is produced industrial, almost like industrial product, precast or prefabricated, precast and brought into the site and fitted. So panels you can form, and it's lightweight, so good insulation property. Then insulated wall panels. This is actually kind of a form itself acts as an insulation. So within the, not forms itself, the next one is the form itself. I have just put in, it's a precast system, or even in a cast-in situ system, the insulation is coming in between. So this is multifunctional. These are all multifunctional. These are multifunctional, not necessarily all precast, but multifunctional system. An insulated precast concrete wall panel or sandwich wall panel is a precast concrete wall panel with two layers of concrete separated by a layer of insulation, rigid insulation, maybe polyurethane foam or expanded polystyrene, but then fire issue has to be looked into. Fire issue has to be taken care of in buildings. So this is how insulated wall panel. But insulated foam is the other one. So anyway, multifunctional can combine load-bearing action with insulation function, dimensional accuracy, thermal efficiency, right? So thermal conductivity values are given of the insulation, hence U value will be less. This is for insulation only. Quality controlled in manufacturing and all that. And you can design the custom design. Speed of construction is high. It can have good time lag, damping properties. So that's depending upon how you designed it. This is insulated concrete forms, but this is in situ, not cast, this cast in situ. The form itself is an insulation and it remains there. So that's the reinforcement within the form. So wall is created by sandwiching concrete between each of these layers, designed to provide stronger, more comfortable and quiet and highly energy efficient structures. So these are some of the techniques which can make it sustainable. This is the concrete, this is your insulated. So insulated concrete form, right? And there has to be, the form has to be put in place. They should remain there. So plastic and steel rebar, if it is required, it would be there. Then you might have a finish also. So they have to be, the form has to be kept in position. They are not very heavy. So therefore they are kept with the plastics. And their lifespan is very many years longer compared to regular construction. But again, the issue of fire has to be looked into. All this integral has to be looked into. So insulated concrete forms are something of this kind. This is the concrete, this is the this is the plastic ties, and then the firing strips. This is polystyrene, of course, is being used here. And there's some other examples. So multifunctional system this is also, but it's not precast. ICF external walls, that integrated formwork, integrated concrete formwork, insulated concrete formworks. This is one. Some of the construction mentioned uses concrete. Obviously, majority of them uses concrete. And optimal multifunctional design and industrialized construction is possible. All this noise, everything has to be taken into account. structural safety, envelope function, thermal, fire protection. And obviously, when you take all of them, then the cost will be reduced, material consumption will be reduced, and it will be also energy efficient, and therefore low carbon, sustainable system. So anyway, this is multiple functions, structural, thermal, noise control, everything. That's what I said, 3D, precast elements, all are possible, and functional design here is also important. But issue is cost or cost of labor. IBC is one, so it's a industrialized building construction. IBC, the two factors which are important is the labor cost and material cost and plant cost. So there are two factors called C factor and P factor. C factor is cost of labor to cost of the material, concrete, and cost of hiring a crane for a day and cost of skilled labor. So this is the ratio of crane to, this taken as a crane is taken as a typical equipment. So this is the ratio. P factor talks about cost of equipment to labor, and this is cost of labor per unit material. C factor and the other is P factor. And it has been observed that C factor and P factor for various countries are something like this. So for example, Southeast Asia, C factor, which is the ratio of labor cost per unit material, the concrete of course, and this is the ratio of cost of an equipment per unit labor, which is very high. That is, labor is cheap. And Scandinavia, for example, this 1.4 is the cost of material per unit, cost of labor per unit material. That's what we said, and this cost is much lower. And what has been observed is this: so cement therefore they have high percentage of cement in precast building, while we have much less, because this is cheap. C factor, which deals with cost of labor per unit material, and cost of labor per unit material, cost of machine per unit labor, or to cost of per unit labor. So cost of machine is cheaper here, machine is cheaper here, labor is costlier, even in UK. But one interesting fact has been seen, that cost of concrete varies less, but wages vary, of course, and proportion of cement used is a function of higher C factor. Where the cost of labor is high, they found it's fine that P into C is equals to 10, approximately, right? So first one was C factor, which is the cost of labor per unit material. This is cost of machine per unit labor. So this seems to be, approximately 10. This two product turns out to be 10 and constant, irrespective of whether the cement consumption through precast is high or not. Here it is highest, Southeast Asia is less, and it is basically, these two factors are same. Somewhere 30 into 0.25 or 35 into 0.25 will be close to 10. And this is 6 to 10, or 10 into 1. This is 6 to 10, let's say it's 8 into 1.4. So all works out to be 10. And this is usage is less. Here the usage is high. So labor cost actually dominates at the moment. Cost increases as individual house area increases, and specification also, quality specifications rather increases. So it has been seen that fixed context, outside context, and this is also outside context. Anyway, the area as it increases, this cost will increase. So that's what we have seen, and quality increases, cost will increase. So potential reduction in industrialized building construction when you are doing, this is of course European, Comite the International Europe Beton, whatever it is, 2010. Basically, what will happen is supervision cost is 19% you can reduce, right? Okay, to and from movement, there can be reduction possibility. There can be reduction possibility, all this, there's a possibility of reduction. There's a reduction here, logistic optimization. So therefore, the cost reduction occurs through all this. So overall benefits are economic gains and saving of cost, but then non-economic gains as creation of additional usable space, etc., etc. Higher flexibility in building design, future modeling of spaces, and things like that. So intangible benefit can to say aesthetic. You have to see that how it works. And you can benefit, you can grade it, and it can be modeled. In fact, B is the weighted average grade of jth alternative. So if you have number of alternatives, you can actually find out which is best using W, which are weights and given by experts. So you can use process called analytical hierarchy procedure and all that to arrive at this W and which is better. So I think I'll not go into those management issues. Site labor is minimized, so that's uniform progress, HVAC, etc., etc. Somebody can work in HVAC in one unit, others can, electrical services can work in the other unit, and therefore at different location they work, therefore time saving is also there. So there's a saving in construction time, site preparation, M plus N minus 1, where M is the number of work groups, say electrical, plumbing, and just now I mentioned electrical and HVAC group, heating, ventilation, and air conditioning group, and number of modules. So K is so therefore this is given as the number of work groups, N is the number of modules you are working. Now this minus M plus N minus 1 into K, where K is the space in days per module by any work group, right? So T0 is a site preparation, etc., which is fixed. And then since two groups are working and in two units, right? So basically work progress time for, because first time when first group, let us say first group is working in one space, then other group is idle. So after that, when it goes to a second, then the second group is also working. And then at the end, only second group is working. So therefore, time saving, site preparation plus this total M plus N minus 1. It would be given by M plus N minus 1, right? So if there are M plus number of groups working, so if there are M groups working, then, first one, if all M groups have started working, M minus 1 group can actually start. I mean, depending upon the situation, they can start. So it works out to be this into K is the uniform maximum pace in days, whichever job requires maximum time. So there's a time saving also. And you can find out the amount saved by engineering economics calculation. I think I'm not going to, standard deviation will be lower maintenance cost and so on. Better quality means low standard deviation, and therefore will save on cement and things like that. So there's break-even analysis possible. I think I'm not going to this, but I'll come to something else. This already I have talked about, internal mean, external mean, and all that. And hollow core slab, I have already told you that this formula I have told you. Thermal conductivity is important factor. It varies with porosity. Higher the porosity, thermal conductivity is less. That is good, but strength will be also lower. So you have to optimize it. Autoclaved aerated concrete is somewhere there. Ordinary concrete will be somewhere there. When you look at acoustic insulation, transmission loss is given by what is known as mass law. For the material where mass per unit, density is related to density, right? And for multi-layer situation, I am not discussing this in details, the algebra part of it. This is some empirical equation, but for multi-layered wall transfer matrix, you can calculate out. So is the matrix depends upon pressure, sound pressure, velocity of particle velocity as we call it. So for fluid, this is the kind of expression. Solid, this is the kind of expression, this transpose. So there is one matrix here, and this is the transfer matrix. So the calculations are available, but I think I'm not going to that. Fire resistance, some empirical equations are there, but detailed one can go about it. This is the multifunctional I'm talking about. This is the standard fire, and it must perform for certain time against standard fire. So if it's concrete, then this temperature is Tg, delta Tg, increasing this temperature, air temperature surrounding the concrete element. Delta Tc is the concrete element temperature increase. NW is given by this is a function of time. This term is a function of time, and this is a function of space. And this is a function of space, ln ux, where ux is related to the diffusivity, thermal diffusivity of the material and standard material. So this is thermal diffusivity, means K over rho C, thermal conductivity over volumetric heat capacity. So these properties of the material, but this is the function of temperature. In case of fire, this is function of temperature. So anyway, this is what is given, but so concrete temperature, ux is given by this, but this is at ambient temperature. This thermal diffusivity of the standard concrete and the given concrete time and x. So you can calculate out using this formula. Ux is known as the thermal diffusivity concrete. Reference concrete is this, which is taken as this much. And T is the time up to at which you want to calculate out the temperature. X is the distance from the surface. So you can come here, calculate out Nx, calculate out W, Nw, and therefore how much is the temperature of the concrete at a given time at the covered depth or anywhere inside, you can find it out. So fire resistance you can calculate out. For biaxial heat flow, this is the formula. I think I'll not go into this. This will be too much. Anyway, if you want the slides, that will be available to you. Some of these are available. My NPTEL lectures, two courses are there. One is one on acoustics, etc., etc. Other is services, where the fire is also discussed. Thermal conductivity of the bricks increases with density. That was the good old days relationship. And thermal conductivity of fly ash, right? Fly ash formed concrete is something like this. And you can see the scale, density as it increases, thermal conductivity increases. So ordinary concrete compressive strength is somewhere there. Lightweight aggregate concrete, we don't have much of it in India. Aerated, autoclaved aerated concrete, strength is much less, density is much less, strength to ratio of conductivity, right? This is density ratio, FT by FC, tensile to compressive strength ratio. This is tensile to compressive strength ratio. Modulus of elasticity is much less. Poisson's ratio is more or less similar. Thermal conductivity is much less here, much higher here. Lightweight concrete has got somewhere in between. Coefficient of linear expansion, this can vary from 6 to 30, around 10 or so, average 20, but moisture content changes. And these are the properties of aerated concrete. Okay, this thermal conductivity of normal concrete is being shown here. Normal concrete is here, aerated autoclaved concrete is there. So normal concrete, OPC paste, there are literature, and from that we can find out actually in saturated condition it is much higher, dry condition is much less. These values are available actually in literature, or maybe I have calculated them myself. So these are available things. Let us see quickly, because we have about 10 times. Types of aggregate plays a major role in thermal conductivity. Quartzite, for example, you can say very high. Saturated state, it is pretty high. Sand, if you have two types of sand, this is our own work actually. Some of these are our own work. Thermal conductivity varies. with concrete thermal conductivity. So you got to, when you do multifunctional design, these properties becomes important, right? Along with strength. And if there's moisture present, this is the degree of saturation. 100% saturation is here, dry is here, 100% saturation is here. And we have an equation also available. We actually worked on to this. So lightweight, high strength ash concrete with bottom ash, this is what sometimes we've developed. We worked on, and I think it is available in Indian Concrete Journal. We made a publication there. CSF, C stands for cement. This silica fume, this is fly ash and bottom ash. And we try to get a relatively higher strength. So it's multifunctional. So I need strength, I need thermal conductivity or low density. This was possible with this sort of material. We used high strength, material. To get high strength, we use ash with silica fume. And bottom ash is used as a fine aggregate. So this is the cement, but this is only mortar. This is only showing mortar. Silica fume, that's why the cement content is pretty high. It is only showing mortar or perhaps, bottom ash with bottom ash and all that. So it's only talking of mortar. Bottom ash, the moment you put it in, the strength goes down. So this is the cement content in the mortar system. This is the bottom ash, this is the fly ash, this is silica fume, kg per meter cube, and water is somewhere there. So we use water to binder ratio of this, and this for mortar. You can get out of that to even make concrete and things like that. So this is concrete actually, and you can see our proportions are silica fume water to binder ratio, silica fume to basically bottom ash, and concrete we made, with some kind of aggregates. Composite strengths were 56 days, 64, and so on, 70 also we could get it, different types of concrete. So you can actually combine many of these. As I said, it's versatile, three-dimensional. So you can use varieties of material, right? So the material design system is there in that paper, but I don't think I'll go into that. And strength density of concrete containing 6 millimeter aggregate. So you can get composite strength, AICTE, two types. So you can actually design for good strength. Now this is the pores are coming because of bottom ash. They bring down the strength. As your density increases, density increases when we are using other sand or something like that. But in this one, density is much less. But strength is 56 or 70. Thermal conductivity will be much lower, something of this order. Right, saturated state, and this is dry state. And dry state, it could be much less, something of this order. So also high volume fly ash, bottom ash, and phase change material. This is what we have used. So this earlier ones, the paper is available in Indian Concrete Journal. This is available in Sadhana. Sadhana is a journal published by called Science from Bangalore actually. It was what is that? Anyway, forget it. It doesn't matter. So we have cement, fly ash, bottom ash. Then this is the PCM content. So phase change material is one which will like wax. So when you heat it up, it melts and absorbs a lot of heat. And you can actually use this together with the strength one is to, but the moment you put them, the strength comes down. Density comes down, but strength comes down because the reason is that such encapsulated PCM, their elastic modulus is very low. The moment you compress them, the capsule becomes smaller, and this brings down the strength. But optimization is possible. So phase change material, the strengths, order of the strength will show. So for example, one particular case, it shows 3 days strength, 7 days, 26 and 28 and 56 days. But you can generally get around 20 MPa, 20, 30 MPa concrete you can make out of this, made out of this. So design has to be accordingly, right? System design has to be accordingly. So bottom edge, if you use the strength, still comes down. Bottom edge, if you use strength still comes down. So you can have all sorts of combination. High volume fly ash, so you are using about in the cementitious system more than 50% fly ash, 50 or 60, two of them, and then PCM paste, and this is the concrete. So compressive strength 10, 15. So you can get around that strength, not exactly structural grade of concrete, but you can perhaps design them depending upon the system situation. So we did some thermal tests because we want to do it for the block and put in thermocouple inside and all, and saw the heat rise within the oven. It's at the oven surface. So this is the temperature inside the oven, and this is a different material at the outside surface. So there's a kind of heat flow is reduced significantly. So effective thermal conductivity we could calculate. I mean, this is measured conductivity, but thermal performance you can find out with PCM, phase change material. They should be encapsulated in polymeric system, and we don't manufacture that size of microns in India. In fact, this was with some imported phase change material from US. One of the companies was selling it. In India, they still yet to come to the technology of finding, encapsulating them properly. So all that I have said is multifunctional design. Give some examples of the materials which can be used in multifunctional design. The technique was very much there, so I thought I'll cover the technique and a little bit of materials. And industrialized construction. This is what can make it sustainable. Well, thermal issue is important, acoustic issue is important, and if you can use all of them together, design it for all of them, that would be the best, including load carrying capacity. So I think that should finish my discussion. Optimal industrialized construction, that's what is possible. Concrete can provide solution to thermal comfort and energy efficiency and sustainability. Thank you very much. I'm sure you'll have some questions. I think I'm close to one. And if you have some questions, I'll answer them.
Yes, sir. Thank you very much, sir, for your elaborate speech. It's a very nice lecture, sir, actually. I hope this is very useful for all the candidates. And any queries, please raise your queries. Any queries? Please raise your queries if you have any queries.
I'm just trying to see if there is any. Not really so far.
Yes, sir.
Any question? Any question?
Yes, participants, if you have any questions, you can raise your queries.
Either send it through message.
Yes.
Or you can. I don't know whether there's possibility to speak.
Yes, sir. Just I want to have discuss with you, sir. Nowadays we are saying net zero energy, net zero waste, all these things, na, sir. So whatever you have discussed, maximum of them are covering that. So through sustainability, we can achieve this, sir.
Net zero is essentially using photovoltaic or similar sort of solar energy devices which can, store the solar energy.
Yes, sir.
So photovoltaic can actually building integrated photovoltaic. So they can actually, absorb the solar energy and pass it on to the grid, right? So net consumption can reduce down, But it has to be basically the envelope and system has to be designed properly first.
Okay, sir.
Efficient system, and then use this uh, energy capturing or generating, if I may say so, because some of the tall buildings can even use wind energy, wind towers and things like that. So it is possible. It's possible, but people have successfully used it in cold countries where sunlight is there.
Yes, sir.
In a country like India, there's a difficulty in the sense that, not difficulty, it is challenging, not difficulty, I have not said difficulty. We have both the composite monsoon climate. Most of the central and northern Indian portion is composite monsoon climate where cooling as well as heating is also a requirement.
Yes, sir.
So heating is requirement in winter, cooling is requirement in summer, and if you don't have the sun radiation available because of let's say pollution, fog, then this will not work. So it is quite challenging actually,
Mhm.
but
Yes.
it can be done.
Okay, sir. Thank you, sir. And another thing, sir, maximum construction in India we are doing with concrete only, na, sir. So obviously we are thinking for the alternative materials, but even though actually the problem, environmental problems, whatever we are facing, na, sir, because of this concrete construction, they are increasing. So even though we are trying for geopolymer concrete or some other concretes, but any alternative solution is there, sir, for replacing this?
No, but I think the concrete therefore is a little bit misunderstood. Let me just tell you, the concrete is actually. Let me just go there.
Yes, sir.
Concrete is misunderstood. Why I'm saying is, you see, the concrete is not what we understand as simply OPC concrete.
Yes, yes, sir.
If you look at this diagram, which I am showing is this diagram.
Yes, sir.
Now you can have varieties of binder. Varieties of binder. You can have varieties of binder. You can have varieties of binder.
Yes, sir.
So if the binder is one which is a culprit for carbon dioxide generation, you try out different binders and which is being tried.
Okay.
So the concrete is basically a particulate system bonded with some binder.
Yes, sir.
So mostly you are using natural material except the binder part of it. Now if the binder is a culprit, you try to modify the binder, and it has got the advantages that it is moldable. These properties you will not have with anybody else. It is moldable.
Yes.
It is moldable to a great extent. I mean, you can mold it as you wish. Moldable.
Yes.
You can get compressive, as we understand the uniaxial compressive strength. In other words, if you try to push this particulate system, if you try to push this particulate system from all sides, you just can't do anything about it. If you try to push this particulate system from all the sides,
Yeah.
you can't do about it. It can withstand a lot of load. But uniaxial compression is what we talk about. Where you actually test a cube or a cylinder, and the failure is by tension. Failure is by tension. You load like this, the failure is by tension along this direction or along this direction. So it is weak in tension, but triaxial compressive load, it can take hell of a lot, very high. So this is the particulate system. So therefore you can what do you call, engineer it to get all the properties that you like, which most of the other materials can't give. And therefore it is so popular all over the world. It's
Yes.
not in India, all over the world it is very popular, right? So
Yes.
that is the reason. While for example, the Western Europe, for example, they go for steel buildings for quick
Construction.
quick construction. But then Scandinavia, it is not so. Even in Singapore, it is not so. Concrete has found a way. So
Yeah.
prefabricated system has found a place in, let's say, Scandinavia, where 70% of their cement they are using through precast system. So that's it. So concrete, Well, you can replace concrete, but concrete is not ordinary Portland cement concrete. I mean, the binder could be different. The concrete type of system, I do not see there is a possibility because of its moldability and because of the possibility of strength and durability. All issues put together, I am not finding at the moment any kind of other material. Because if you put epoxy and aggregates, that's also concrete.
Yes, sir.
So
Nowadays we are doing that.
yeah, so particulate material bonded with some kind of binder, that's concrete. So that's basically the concrete. And that sort of thing, the kind of advantage you have, you don't have in any one of them.
Yes.
So that's it. But then traditionally people have been using, for example, in Northeast, people have been using bamboo for many, many years actually traditionally. But they get restricted to, let's say, one-story building or two-story. Right?
Yes. Yes, sir.
And also there are the other effects.
This.
You have to grow them. But bamboo is one of the things which has been successfully used. Still, the Britishers in 1930s actually started with what you call bamboo concrete, bamboo-crete, if I may call it. Make a bamboo mat, put cement plaster outside.
Yes.
That's used in Northeast quite a bit. I'm not sure now they use it or not. But point is, you engineer the system judiciously to handle it.
Yes, sir. If we engineer the system, yes, sir, we can. Thank you, sir. Thank you for your explanation, and I hope all are enjoyed this session. So now, if no queries are there, then even if you have any doubts, you can share the queries to sir mail ID. I will share with you. Thank you, sir. Thank you for your wonderful lecture, and I am once again saying thank you from our organizing team from NIT Silchar. Thank you for your cooperation and support. Thank you. So now,
Okay, good day. Right.
I think now we will close this session, and we will meet at 2 o'clock. From 2 to 4, we have a session, and in that, Professor Hadi Muhammad is going to give a lecture, University of Yallang, Australia, effect of internal FRP reinforcement and different loading condition on the behavior of FRP tube confined concrete columns. So that is the topic. So I hope all of you will join at 2 o'clock. So thank you, sir.
Thank you very much. Okay then. Bye-bye.
Yes, sir. Bye-bye. Thank you, sir. Thank you.
Thanks to all participants.
Yes, sir. Thank you all. So please, all of you join at 2 o'clock for the next section. Now you go for now
we have to join
1 to 2. We have lunch break. Okay. Thank you.
Is there any other link or same link we have to join?
Same link. Same link.
Okay, thanks. Bye.
Right.
Few good things that we did. We had good things to do. It is more flexible. We can move whatever we want. There are channels every meter, so we can fix wherever we want. Now I'm going to stop this one, and I'm going to go to the other presentation. Please, if you have questions, please ask me. And I'll do this one, a window and PowerPoint. And share. Okay, so the work that I'm presenting is from my PhD student. Currently, he's in Lahore, in Pakistan. He's an associate professor. His name is Qasim Khan. I'm going to present the work that he did within about 4 years. So in his PhD candidateship, in his PhD studies, the amount of work that he did. I'm going to show you the amount of work. In a nutshell, there is a main thrust of the thesis, which I'm going to present to you. Then I'll show you how a good student can come up with different shoots. Like you have a tree, there is the main trunk, and then there are shoots, and there are other things. So he published his main experimental program. Then he was able to publish other papers which are not from the main thrust of the thesis, not from the main branch. They are from the sides. This indicates to me that he is a top PhD student. So the supervisor is Professor Sheikh. So we work together, and it doesn't matter who is the first supervisor. There are duties that we have over the years. So for example, thesis, I should take care of the thesis fully. For papers, I read the paper first, then he reads it, then I read it again, then I submit. So there are some revisions when it comes to revisions of journals, the other way around. He looks after them, then I read at the end and I submit. So there are the roles are very clear. I do this, he does that. So it is very clear. The main thrust of the work of Qasim, or Professor Khan, was to use FRP tubes in concrete columns. So the main thrust is this. Okay, why FRP? Because of corrosion. So I told you we have a bridge. Whenever there is water, marine, salt, there may be corrosion. So this is the reason we are going to use different materials. So the different materials is, in this case, FRP tube. So Qasim came up with this idea. So as I said, I believe that the best material is reinforced concrete, steel reinforced concrete. But if there is areas like Wollongong, like Sydney, near the water, near the marine, then we go to these materials. So there are three parts in this presentation, and you will see the three parts, and you can see how we go about it. So FRP, fiber reinforced polymer, it is good material, it is strong in tension, it is light, it is not electromagnetic, it doesn't corrode. Admittedly, it is brittle, right? But steel, the tensile strength of steel is 500 MPa, whereas the tensile strength of FRP, GFRP 800, where it is CFRP, it goes to 1500 or more MPa. So FRP, yes, it is brittle material, but the strength is much higher. So if you use a proper design, then we can come up with proper design. So believe it or not, in 1928, a gentleman called Richard, not Richard, Richard with a T, he came up with this equation. And I always tell my students, the main thing in civil engineering, sigma fx, sigma fy, sigma moment, these are 0. So if you take sigma fy is equal to 0 and you sum, you will see that the confinement in the stress in the tube will be applied on the concrete. Of course, this is based on Poisson's effect. And we have all this idea in on the right hand side, the curves, you can see if we have confined concrete, this is the behavior. In effect, you are changing if it is unconfined, it is axial, uniaxial loading. What if it is confined, it changes from uniaxial to triaxial. So due to Poisson's effect, you have higher strength. And there is this relationship between the confinement ratio and strain reduction. So it is the relationship between the FL, which is the confinement stress, over the compressive strength of concrete. This comes from that equation, which is just sigma Fy is equal to 0. And then you have the strain, rupture strain, divided by the ultimate strain of this is called strain reduction factor. So FRP, there are advantages: high tensile strength, high corrosion resistance, durable material, and actually mechanical engineers have been using it before us. They used it for repair of aircraft. They use the FRP currently, one of the Boeings, it's mainly all FRP. And they use it in cars as well and in boats, fiberglass. Now, this FRP bars, ACI 440 in 2006 clearly said don't use FRP bars. But the current ACI 440 doesn't say use or don't use. It is just, it's silent about it. Canadian standard says, okay, you can use it, but you ignore the contribution of the FRP bars in columns. So in this case, you take only the 0.85 F prime C, which is the compressive strength of concrete, and you multiply it by the net area of concrete. And you ignore the effect, usually we have the AS FY or FSY, or FRP, AFRP, but in this case, we don't take it. Now, when Qasim started this work, we said, okay, FRP tubes, being a civil engineer, being a civil structural engineer, there is something called fire. And fire is a problem. So the bars, at least if you have beam column inside the members, FRP bars inside members, then there is cover. And this cover may protect the bar from fire for maybe 1 hour. Whereas if the FRP is outside, then if there is fire, then you will lose the material. So Qasim did some preliminary study, and then there was some additives, chemicals, lightweight concrete you can apply on the tube to reduce the effect of fire, to allow people to run away. So let's talk about, I'm going to start with experimental program, and you will see there are two types of, two components of this. So we had carbon FRP tubes, glass FRP tubes, glass FRP bars, and carbon FRP bars. So what we did, we have the material testing, which is the preliminary testing. Then we go to the main testing. and I'll show you what we did in the main testing. In the preliminary testing, we tested all those materials. And in the main one, we had the columns, and they were 812 millimeter height, 203 millimeter diameter. And this is carbon, and it is FRP, and it is filled with concrete, and it is tube. And then there is the other one, the reference, which is steel. So we had steel and we had the FRP. Now, material testing, we did some standard testing, and we had the bars, which are 9 millimeter and 15 millimeter and 15.8. So the 9 millimeter is carbon, 15 millimeter is carbon, and glass is 15.8. And this is compression. So we had them by themselves, and we wrapped them, and then we tested them. Because this is compression, and these are fibers. So we thought if we wrap them to increase the integrity of the fibers. You can see the clear length of those is very small. The highest is 80 millimeters. The old systems have 3 inches. It is not a big deal. So we did those. Now, for the tension, it is a different story. You can see for the, for example, if you have the 15 millimeter, you have clear length of 600 mil. Then on top of that, there are the anchorage lengths. So for those, we built steel tubes, we put the bar, and then we bought expansive cement, and then we put them, leave them for 3 days, not longer, and test them. If it is longer, you will have problems. Now, I was telling you that there is the main experiments. Qasim came to, this work is based on ASTM. ASTM has up to 12 millimeters testing. They don't have for 15 millimeters. And Qasim did this test, and we wrote a paper, and we sent the paper, and we published it to ASTM. This is not his main test. This is not his main program, but he was able to publish a paper in ASTM saying, adding to the standard. So these are the tests, and then where are we? Sorry. Then we did compression testing. We have small tubes. They were about 150 millimeter. The height's about 300. Carbon and glass, and we filled them with concrete, and we tested them. Now, with different thicknesses of tubes. Now, this is the main program. So in the main program, we had 2 main groups. The first group is carbon, and the second one is glass. These are the tubes. And for specimens, just carbon, we fill it with concrete. Then carbon with carbon bars. Then glass only, and then glass with bars, glass bars. Then we tested one specimen from each group as column under pure compression. Then we applied 25 millimeter eccentricity. 50 millimeter eccentricity, and the last one was 4-point bending. So we did all those, we tested them. And then the next thing we did, as I said, we had one group of specimens, which is reference. And here we used 200 millimeter diameter, height 800. And the 6 and 12, N is our deformed bars, 12 millimeter deformed bars, nominal tensile strength 500 MPa. And we had R10, R is nominal tensile strength 250 plain bars, and diameter 10 millimeter, and spacing 60 millimeter center to center. So these are some results. I'm not going to bore you with the results. These are the glass FRP. These are the carbon FRP. Then this is for the FRP bars. As you can see, when I told you that we have 2 meters, it's good we have the 2-meter head, 50-ton machine. Otherwise, we will not be able to test them. And then this is for the FRP bars. This is for the carbon. And these are for the tubes, which are concrete filled tubes. This is the carbon one, and the glass one with the different thicknesses. Then this is the main testing. We used the, when I started, I told you this is a machine, 500-ton machine, and we test them. There is, of course, it is deflection, displacement controlled, and we apply the load, and these are the axial deformation and the axial load. You can see that we have achieved better than the reference. We have achieved better than the reference in all cases. And this one, we take the under eccentric load. This is 25 millimeter eccentricity. Again, you can see that we have good results. And this is 25 millimeter eccentricity. And this is for 50 millimeter eccentricity. And again, for the glass. And this is the flexural 4-point bending. And you can see we have good results in all cases. So this is the for the whole 25 millimeter. This is for the concentric 25, 50, and in all cases we are doing. I think we did good job. Now here the student finished. He did experimental. He published a couple of papers. He had other net main testing, the FRP bars. He published it in ASTM. So it is good enough for a PhD. Now, what he did, he said, okay, let's look at different thing. So he looked at interaction diagram. And he drew the interaction diagram as 4 columns. So pure axial and pure bending. And this is the experimental results for all the results that we have.
So if I go on speaking, so much biodata is there. So I want to brief out this. And next, I am handing over this session to Dr. P. Swami Nagaratnagiri. Sir, welcome, sir. Welcome for this the third session of this FDP.
Thank you, sir. Thank you for giving me a great opportunity for both the coordinators, Dr. Hussain sir, and as well as L.V.PRASAD sir, for giving us such a great opportunity to deliver my whatever the things I have done up to in the past 7 or 8 years onwards in the leading sustainability aspects. And I also welcome all the participants in this FTP for listening my lecture. So shall we continue or we will wait for some time, sir?
Yes, sir, you continue, sir. Because we have two links, sir, actually, because this Google is having 100 limit, so that's why we are sharing from two links, and almost in one link, 40 students, in one link, 35 students are joined. So no problem, sir. They are joining. You carry on, sir.
Thank you, sir. Thank you for your great explanation about me regarding my introduction. So that's the things we can go on. So today I am going to discuss about diversion towards sustainability in concrete making materials. So So in generally, when we talk about the sustainability, because today's FDP is on how to make a sustainable development in civil engineering aspect. So as a civil engineer coming to the research of concrete, so I want to make a concrete with sustainability materials. So in that regarding, so much of research is going on. So still it is going on. So before that, we want to understand why the sustainability is needed, whether we are going wrong at this any point. So in generally, when you go to the all will talk about sustainability is because of using of more amount of natural resources or otherwise the emission of global warming, CO2 emissions. All these things comes under the picture. As we are civil engineers, we know that the only one material that is the concrete which produce so much of global warming, so that we have to reduce that in several aspects, not only single aspect. There are several things should be considered to have sustainability in this global scenario. So coming to the in these situations, so we should heard about what is mean by earth overshoot day. So in generally, earth overshoot day is one of the factors should be considered throughout the globally, internationally. So this the day where we are going to give the caution regarding the sustainability. So it's a very easy thing to find out what is meant by earth overshoot day. So in generally, the world biocapacity, that means how much amount of resources is produced by the earth for 1 year is utilized by the humans. So it divided by whole ecological footprint. So into 365 days, that it comes under earth overshoot day. So in generally, for every year, they will be having one earth overshoot day. What is happening to our earth? So whether we are using the same quantity of natural resources which are produced for 1 year, because earth will produce every year for natural resources for human beings, but due to of fastness or increasing of urbanization industrialization all over the world, we are very faster to utilize all the natural resources. So because of this, we are lagging using the resources, and we are not up to the mark to use the same level. We are dragging out of so much of materials from past futures generation material. So this is one of the data which is procured from the resources of global. So initially for this year, already our earth overshoot day is completed at July 29th. This represents that. What is this July 29th is representing is that, so already whatever the material is produced by for this 2021 by the earth, it is already utilized by the month of 29th July. So the remaining months we are using the resources from the future.
Professor Gili, sorry for interrupt. You are changing the slides now?
Sir.
Now only you are changed, or because that slide change is not visible to us. Now it is came.
Okay.
At overshoot day. Yes.
Yeah. So in general, this earth overshoot day.
Excuse me, sir.
Sir.
Please put your PPT in presentation mode, sir. Then we can able to see clearly, sir.
Is okay now? Is it okay?
No. Last, the top left side, one mug type symbol is there, na, sir.
Okay.
Screen top left side, one mug type symbol. If you click on that, it will come on the presentation mode, sir.
I already click on that one, sir. Now it is coming or not?
Okay, sir. Here we are seeing entire your screen, sir. Just presentation mode. Can you able to see top, sir? Left side, top corner.
Yes.
There is one mug type symbol is there, na, sir? See, 1, 2, 3, fourth one. Top corner left side. Top above the, I think, title, I think so. File
I think
above the,
that
yes, yes,
this
sir.
Is it okay,
problem
sir? Is it okay, sir?
Yes,
Is
sir.
it okay? Sir, is it okay?
So otherwise you increase that percentage, sir.
Sir, is it okay
Increase the
now?
percentage. Increase percentage.
Uh, yes, sir. Actually, it is not in the presentation mode. Actually, can you do one thing, sir?
Sir, is
Just
it okay now?
you stop your presentation and once again you go, sir. Sometimes technically it will create problems, sir. Just you stop presentation and once again you share, sir. So automatically it will show. These are the some technical issues actually. Sometimes it will show like that.
Sir, is it okay now?
Yes, sir. It is coming now. You are in presentation mode.
Yes, yes.
Still actually it is showing the like that only. Okay, you continue, but you change the slides, sir. Actually, this problem is there in some laptops actually.
Sir, is it
But
okay, sir?
size is okay, but you reduce small because that slide is missing. Somewhat reduce, sir, size.
Okay. Is it okay, sir?
Now it is okay. Now it is okay, sir. Yes. Please carry on.
So generally this earth overshoot day will measure in terms of how much amount of resources we are utilizing for producing by 1 year and how many number of materials they are producing. So in this scenario, in this world now for this year 2021, already we have gone out 29th July as 2021 is the earth overshoot day, and the remaining months we are utilizing from previous years generations materials. So this, it should be not be very good for our earth. So it should be utilized as long as per the resources which are used according to the production. So generally, coming to the different countries, they are China, USA, UK. They are using so much of 1 year. In general, we have to use 1 year, but USA they are using 5 number of years, and China they are using 2.3. Like this, so much of countries they are utilizing more amount of materials for rapid increase in the urbanization, transportation, population. Because of all these reasons, there is this earth overshoot is coming, go on. It is going on to the up to the previous June, July like that, but it should be come back to the December again. The Indonesia is the country where it is using up to December 18th. So that is one country where it is utilizing only the small amount of materials. So this is how the scenario, what is happening to the earth. So in January, we are having utilizing the full February, we are utilizing the back of March and March, April, May. So at the end of the July, our batteries get dead. We are unable to utilize the materials which are produced by the earth. So that should not be happen, because if at all it is going to happen, we are unable to process anything else in this scenario. So because the reason because of this is because of we are having mismatch in numbers. So whatever we are utilizing, we are unable to come up to the demand. So supply is very less when compared to the demand because of rapid increase population. So there is less numbers on the supply, and where the demand is more and more by so much of increment in the utilization. So coming to the why this reason of this sustainability is coming to the picture. Because of main industrial revolution, the world has witnessed so much of incalculable technology achievements. That is, technology is rapidly increasing because it is not a calculated achievement, because it is uncalculated achievement. And there is a population growth, corresponding increase in the resource always. Whenever your population is increasing, at the same time your resources are also increasing. So because of all these reasons, they will be having some side effects, some like pollution, landfills at capacity, toxic waste, global warming, resource and ozone depletion, and deforestation. So these are all things that are side effects which causes because of revolution, industrial revolution. So all these efforts are straining the limits of Earth's carrying capacity. That's the main reason why we have to concentrate on sustainability. So where this is the main cause. We should able to understand what is happening to our Earth. So it is ability to provide the resources required to sustain life, but while retaining the capacity to regenerate and remain viable. That should be considered. So these the construction industries building factors should be considered. What is the
Dr. Giri, now
Sir,
you are in which slide?
sir, I'm in 8th slide, sir.
Sir, better you change from the slides. Number is there, na? Left hand
Yes.
side. So
Yes.
from there you go on changing, sir, because
Yes,
that change we are not able to see. Sorry for interrupting.
Sorry, sir. So 8th slide is visible now. Building industrial facts. Sir, is it visible? Building industry facts.
Yes, sir.
Yes,
It
sir.
is visible, sir.
Okay. So,
Sir, can you just show from 4, 5, 6 slides, because they have not seen that slides.
Okay.
After
Now it
3,
is-
sir. Yes.
is okay.
So do one thing, sir. Whenever you are presenting slide number, please click on that slide, sir.
Yes, sir. Okay,
Then
sure.
only we can do this.
Sure. Thank you, sir. Thank you. Definitely. Yes. So now this is the 4th slide where I'm saying about Earth Overshoot Day. So that is about in this year we already consumed whatever the materials which is produced by our Earth is up to 28th itself. Because of the that is why our 29th July is saying that it is Earth Overshoot Day. It is already completed. Whatever the resource which is generated, it's already completed by 29th of this 2021. Remaining months, we are depending upon the future generation materials only. So that should be extended to the December, not to the January. So that is one of the drawback we should be considered in each and every aspect of materials. So this is the reason what is the happening. In January, we are utilizing, February, we are utilizing March, we are utilizing from April to May, June, up to end of the July, we are totally dead. We don't have any type of materials to utilize. So that is the reason why we should focus about sustainability. What is the mean by sustainability is mainly if you are using recycling materials, sustainable materials. Definitely this July month is comes to the August month comes to September to October. Definitely will come close to the December. So that's what we required from the sustainability. So what is the reason for this utilizing of the material is because of mismatching in the numbers. So there is a huge amount of demand when compared with the supply. So whenever you are hitting huge amount of demand, definitely the supply is also should be in the same level. But we are unable to supply the according to the demand which is having in this dose in million cubic meter units in billions. So that's the reason. And you take any type of material, you take the aggregates, coarse aggregate, fine aggregate, sand, bricks, anything else. So the demand is very high, but supplementing is very less when compared with both. Both should be equalized. That then you can be managed with the materials. So this is the main concept we should be focused. This why it is happening because of revolution in the industrial increment, technology improvement. So all these things comes under to the main aspect of this effect. So what is happening if at all there is a increase in the technology achievements? It is incalculable. That means we are increasing the technology but unable to calculate what is happening with the technology. So again, another reason is the population growth, corresponding increase in the resource use. So what type of resource are you using? That should be responsible and we should utilize according to that. So what will happen if you are not bothering about all these things? What will happen? Definitely there will be increase in the global warming, pollution, landfills, toxic waste, resource and ozone depletion and deforestation. All these straining effects will be happen to the earth carrying capacity only. So all will again hit to the earth, so that earth will be cannot withstand all these things, and the starting of the depletion of all these things will be comes under. So these are the building facts which are responsible for us. So we should look after that. So because of increase in the population, vegetation, air quality is lessening day by day, transportation, climate, watershed managements are unable in a proper channel. So in of all these, 1/6 of the world's freshwater are withdrawals because for the construction activity. 1/4 of the world's wood harvest is taking only for the construction activity. So we are the civil engineers. We are the responsible for all these activities, and we should look after in a sustainable way, alternative sustainable materials. And 2/5 of the world's material energy flows for only the construction activities only. So these are the building fact industries where you should look order, and according to that we should think alternatives. not to depend upon again and again to the natural resources only. So what is meant by sustainable development, which is given by the Brundtland Commission in 1918 itself? Development that meets the needs of the present generation without compromising the ability of future generations to meet their own needs. This is the best statement which can say several times. Sustainability means this is the first statement we can give. We should utilize whatever the materials is available in the present days. We cannot go on using of whatever the material is available. That should be provided for the future generation. That should be talked out. And if at all you want to conclude this sustainability should be happen, then you have to look after several aspects. One is the integration of environmental concerns and green construction. That should be very much should be understand, and you should be focused how to make a construction to the green construction. For example, if you want to make a concrete, you go for adding of mineral admixtures, makes amount of decrease in the emission of CO2 from the manufacturing of OPC. That is one type of green construction only. Utilizing of low energy resources, using of some alternative techniques and less energy efficiency techniques and healthy structures. We should not able to construct like a huge amount of structures and say tall structures. All we require healthy structures. Building longevity, waste reduction should be there, recycle should be done perfectly in all aspects, water conservation should be done. For this, achieving for the sustainability, all these things are very much important and very required for our future generations to make a very comfortable life. So to achieve this sustainability, so what are the different applications point of sustainability should be considered? When you are pre-designing, you should focus on material selection. Before designing, you should focus about alternative material selection. Building program should be developed in a particular manner. Project budget should not be go on increasing. That should be controlled. Team selection should be appropriate and very perfect. Partnering should be done perfectly. Project scheduling, laws, codes, all these things should be done pre-design, and on-site design, construction, and maintenance should be done very perfectly in all aspects. If at all you've done all these things as per the guidelines at the Model Provisions, definitely we can achieve and some sort of sustainability for the future generations. So these are the advanced features of sustainable building. So first, best building form using of solar energy efficient design, improved indoor air quality without providing ACs. That is one of the important, by providing proper ventilation. Improved indoor air quality is very important. Usage of green materials, proper mechanical systems, efficient lighting, proper testing and maintenance. These all are the advanced features of making sustainable building. So coming to the green materials. So materials. So in generally, what is meant by green materials? Nothing but is are using of use and disposable must be safe for the planet. So you have to concern about different types of disposable, non-disposable materials which should not be harmful to our earth. So that should be concentrated. So most of the materials have specific range of conditions in which they can their best work. Sustainable building materials have the following features. So definitely, if at all you are using some sustainable materials, it should have durable and easily maintained. Less processing should be required. Less order, low emitting, cost effective. These all things should be considered, and aesthetic. It should be aesthetic. These are the basic things should be considered in designing of your green materials. So coming to the economics of green materials. So coming to the economics, so if at all you are using some green materials in the green building, so what is happening? So reduction in the lighting energy requirements, at least we can reduce the 50% if you are using some sort of alternative techniques for lighting energy system. So definitely you can reduce the 50% of energy emissions, and cutting heating and cooling energy consumption by 60%, reduced water consumption by up to 30% or more, low building operation expenses through reduced utility and waste disposal. So these are all some of the economics should be considered before you are going for green buildings. That should be considered in all aspects. So coming to the future of sustainable buildings is always, I can say, is future research is always what are the research we are going on in different aspects of building materials. So that will be helpful for future of sustainable buildings. So there's successful examples of sustainable buildings, never efficient or healthier technologies, availability of computer software programming, and identify.
Gopal Behra sir is currently working as an associate professor in Civil Engineering Department, Government College of Engineering, Kalahandi, Bhawanipatna, a college of Biju Patnaik University of Technology, Odisha. It is under the Biju Patnaik University. Sir is completed his PhD in 2010 from NIT Warangal, and his research area also torsional retrofitting of flexural members. Then after that, Sir is completed. That is the master PhD and master's degree ME in structural engineering from Bengal Engineering College, Shibpur, under Calcutta University. Now IISc Shibpur. After that, Sir is completed his that is master's degree BE from OUAT CET Bhubaneswar in 1990, and he has having more than 25 years of teaching and research experience in the field of civil engineering. His research interest areas are composite structures, self-compacting concrete, retrofitting of structures, fiber reinforced concrete, sustainable concrete, torsion of RC members, recycled aggregate concrete, ferro cement structures, sustainable practices in civil engineering, high strength concrete, and still he is doing so many new areas of research, and he is guiding some of the post research scholars and MTech students. He has published more than 60 research papers in various national, international journals and conferences. He has published a good number of books and book chapters. He guided more than 15 master's degree students. He is also a member of some professional bodies like ICI, ISTCE, and a fellow of Institute of Engineers, India. And he is also a reviewer some of the reputed journals, and so we are very lucky to have a experienced person with us. Welcome, sir. Welcome for this 5 days FDP, and I'm handing over you for starting the session. Please carry on, sir.
Thank you, Prasad sir, for your nice introduction. Okay, thank you, the Civil Engineering Department, NIT Silchar, for giving me a chance to present this paper before the audience. Thank you, sir. Shall I start it, sir?
Yes, sir. Please carry on, sir.
Prasad sir.
Yes, sir. Sir, it is visible. If you have, if you do not have any network problem, then you switch on your video also.
Okay,
if you have any problem, then you switch off. Otherwise, you switch on video also, sir. So that we are taking the video recording, so that it will come along with your presence, sir.
Just 1 minute. Eh?
Yes, sir. Yes, sir. Thank you. Go to the presentation mode.
Okay.
Yes, sir. Nice.
So, let me start the topic. If you see the topic, ferro cement, a sustainable material for torsional retrofitting. So, myself, Dr. G.C. Behra, as already introduced by Prasad sir. So, there is no need to go for this. Now, if we go through the outline of the presentation, first one is introduction. Next one is upgradation of torsions, structures. Then white torsion, materials for repair, ferro cement as URAF, methods to quantify, and the conclusion. Now, if we'll go through this, we will find what is our basic needs: food, cloth, and shelter. Nowadays, shelter materials, if we go through the shelter, so we will see globally it is increasing the population 1.1% per year. To fetch the shelter to this.
The chairman of the committee. Anyway, this is my mistake.
Sorry, sir. Whatever it is available, that is.
Yeah, I understand that. So thank you very much. It is a great pleasure and honor for me to join you for this very important conference on, I should say, sustainability. in civil engineering. So I selected this topic based on the theme of your conference. So this work I have been doing for last 20 years on scrap tire recycling. So I selected this topic wishing that some of the young researchers will continue doing research on this topic. Okay, let me share my presentation file. Something wrong. Just give me a few seconds. Okay. Can you see my screen?
Yes, sir. Yes, sir.
Okay. Okay, thank you very much once again. So my topic is earthquake-induced disaster mitigation through cascaded recycling of waste tires.
Sir,
I'm not
sir,
sure.
Can you make it in a full skin?
Oh, I made in full screen, but let me try it again.
Yeah.
Okay. Yeah, I don't know what is happening. Something wrong.
Sir, it is in full screen only, sir. You
Yeah.
go to full screen.
Okay,
Yes,
okay,
sir.
okay.
Okay, now it's okay.
Yes, sir. Yes, sir. Manohar, sir, it is in full screen only in our system.
Okay. Okay, thank you. So this is my topic. I'm not sure how many of you have heard of this term cascaded recycle. So let me explain to that before I move on to my research topic. Okay. So what is this cascaded recycling and why we need this kind of recycling of waste tires? Okay. This is the flow of the recycling process, I mean, from the manufacturing to the recycling. You have the resources of the scrap tires, original rubbers. Then from there, you finally get the manufacturing product, which is in the form of our tires for automobiles. And then it comes to service provider, and then it comes to consumer. Okay, so once we consumers use those tires, after 10 years, 15 years, it becomes the waste, kind of industrial waste. But of course, we can use them. We can reuse them and bring it back to the service provider. Or sometimes we can refurbish them. And we also sometimes get the original rubber from the waste tires and provide them back to the parts manufacturers. So these are some of the recycling process of waste tires. Okay, but this recycling is very, very tiny percentage of entire recycling process of the scrap tires. So most of the scrap tires or waste tires now are used for energy recovery. That means we are burning these tires to get the energy, especially in the cement manufacturing companies. They need a lot of heat energy. So they burn these tires to get those energies. And sometimes in some countries, they do a lot of landfillings, especially if you go to Middle Eastern countries. They do it, or so they just dump it in the desert. So these are all what I can say is not good to our environment, because once you are burning the tires, you are releasing a lot of CO2 to the atmosphere, which is harmful to our environment, and it's a negative factor for the climate change. And also landfilling also had a lot of problems. I'll come to that. So instead of recycling the same tires as the same product, we can return these waste tires on different products. And that is called cascaded recycling. Okay. For example, we can use them as material to improve the ground in geotechnical engineering. And in recycling, we can make them in different sizes. Like if you make it very, very tiny particle sizes from 0.3 to 12 millimeter, then it's called granular rubber. If you make it from 12 to 76 millimeter size, then it is called tire chips. And if you make it more larger size, like a size of gravels, then we call tire shreds. These are three different materials, and I call them as scrap tire derived geomaterials, STDM. Okay. And this is the recycle scenario in Japan. It's a little bit old data, 2019. You can see that this green part, most of the recycling are for deriving the energy. It's a thermal recycling process. And some of them are used, some of them are exported, okay? And rest are unknown. So we need to we need to go for a recycling process which is not bad for the environment, which is not going to destroy our environment. So thermal recycling is not the ways of the recycling that we in this earth now are expecting from the industries. Okay. In this scrap tire management, as I told you before, it has a lot of problems. First is the landfilling. It has an increasing risk of health hazard. All the mosquitoes and other those insects, they come there and take heavens inside the tires, and also this kind of exposed landfillings increase the risk of fire hazards. And we have this recycle of tires as thermal recycling or material recycling. Okay. As I mentioned it before, thermal recycling increases the emission of greenhouse gases. So we need some resilient and sustainable ways to manage this kind of construction resources. And by doing that, we can reduce the climate change induced geodisasters. For example, heavy and torrential rainfall. So this kind of sustainable construction, to manage this kind of sustainable construction, we need some resources which are low cost. Okay, that makes it a budget friendly. Also, which are low carbon footprint materials that makes it to an environmentally friendly material. So these scrap tires or waste tires derived geomaterials are recycling it, and at the same time it's a low carbon material because we are not burning them, we are using them as a material which can improve our ground. Okay. This is the cascaded recycling of scrap tires. Now let me go to the main research topic. I have been doing this research for a long time, especially the application of scrap tires towards earthquake-induced disaster mitigation. So some of the application includes liquefaction protection of layer around water supply system. Some researchers are doing that. Lightweight backfills in retaining wall or fills for lightweight embankment. And few of them, these related references, you can find these my papers in 2007, 2008, and 2015. And the first ever dynamic application of tire chips as cushion against earthquake protection of gravity type retaining structures like key wall, okay, in the port was introduced in my paper published in ASC Journal of Geotechnical and Geoenvironmental Engineering in 2008. The paper, the technique that I suggested in that paper is that you can use tire chips as cushion against this kind of key wall. In case of port structures, you have the backfill and the key wall, so you can use the tires as a cushion to protect it from earthquake. And later on, I modified that technique. First, I suggested that you can use these tire chips as cushion. Then also I suggested that you can use tire chips as a drain to dissipate the pore water pressure, excess pore water pressure generated during earthquake to mitigate the liquefaction, which I referred as vertical inclusions. We're putting them as vertically inside the ground, either as cushion or as drains. And this was few of these research were published in 2010 in geotextiles and geomembranes. Later, I have developed a new technique, which is called isolation technique, using a horizontal inclusion. Horizontal inclusion means you have the buildings and you have the foundations. Then if your building is situated on sandy soils, which are likely to liquefy during earthquake, to protect this kind of buildings, we can use those tires as isolation layers, tire chips, or mix tire chips with other materials such as gravel or sand.
Yes, sir. Hello, sir. Murali Krishna, sir.
Yeah, hi, hi.
Yes, sir. Yes, sir.
Yeah, it is
Welcome.
disconnected. I didn't notice.
Yes, sir. Good afternoon. And welcome to, sir, in our FDP program. Our today's speaker is Professor Murali Krishna, sir. Murali Krishna, sir, is the professor and dean at the Department of Civil and Environmental Engineering, Indian Institute of Technology, Tripura. His research interests are earthquake geotechnical engineering, geosynthetic and ground improvement, physical and numerical modeling, site characterization, and other. He earned his PhD degree in year 2008 from Indian Institute of Science, Bangalore. His MTech and a BTech from Indian Institute of Technology, Kanpur, and BTech from Sri Venkateswaran University, College of Engineering, Tripura, in 2003 and 2001, respectively. He is a life member of Indian Society of Earthquake Technology and Indian Geotechnical Society. He has successfully supervised 7 PhD students, and a number of students is ongoing. And he has published more than 30 international and national level journals, very reputed, and number of conference paper articles, and 3 more good books he has published. So, sir, CV is a very big once a very small introduction. So, please welcome to once again. Welcome to Murali Krishna, sir. He is going to deliver his lecture. Today is geosynthetic materials for civil engineering applications. Sir, please hand over the sessions.
Okay, thank you, Dr. Manohar Hussain. It's very nice. I hope I am audible, right? It's
yes, sir. Yes,
okay.
Yes, audible.
Thanks for the outset. I thank all the organizers for taking up this very apt course and also inviting me to take part of this FDP program. Yeah, Dr. Prasad was following with me regarding topics and confirmation and so on. Finally, today the event were happening. So, in spite of the difficult situation, what is prevailing, the efforts made by the organizers are significant. I saw the inauguration program where Dr. Prasad was mentioning in future, all you people should be visiting the campus and physically interacting with the thing. We're looking forward to such physical interaction sessions.
Yes.
Good. So, yeah, let me share my presentation.
Yes.
So, how many participants are there total?
Actually, 200 plus, sir.
Okay.
We have 2 links. This one and another more link is there, because.
Okay. So, why they are split into 2 things?
Yes, sir. Yes, sir.
Okay.
Sir, actually there is a limit of 100 only, sir, in Google. So
okay.
That's why we are sharing again another link we are sharing for other people, sir. That's why the other number is also in other Google Meet link, sir.
Oh, so they are also seeing now. Okay.
Yes, sir.
Okay.
Just we are sharing this, sir.
Okay. Good. So, welcome you all. So, how are the participants distribution? They are all from the faculty level, or who are all the participants? Just to
yes,
get the
maximum them are faculty, sir. Maximum percentage 80% they are faculties, and remaining 20% some research scholars, MTech students are there.
NIT scholars, NIT.
Our some NIT, our scholars, some back NITs, IITs also there, sir.
Okay, very good.
Like almost all states it is covered, sir. 200 itself it is registered from the website only, sir. And
excellent.
200. Then internal we have registered some more people by providing a Google Meet link, sir.
Very
Google form, sir.
Very good. So thank you, Dr. Prasad and Dr. Manohar.
Thank you, sir.
So welcome all the participants for this third day of the event. We are in the second session, third day. I think morning we all enjoyed a very interesting session by Professor Hazarika, showing very experimental studies on how to use the type-derived materials as a geotechnical material, as a sustainable material. That's a very good demonstration. So just to take the topic, as a innovation in civil engineering materials and techniques for sustainable development. So I thought I would focus on geosynthetic materials, as the other speakers are not really touching this geosynthetics content as a material. So I took that opportunity to select this topic. So my title of the talk is geosynthetic materials. I just include the sustainable civil engineering applications. So all the applications, if we need to make the sustainable use of geosynthetic materials, would help to get the targets for achieving the sustainability. So that let us see. To some extent, I will throw some of our recent studies and our findings just to as a informative purpose. Yeah, the content of my presentation is organized like this. Briefly, we'll see what is sustainability. And of course, after my talk, there is a very authenticated professor to talk about sustainability and related things. Professor Krishna Reddy, he will be giving much more insight on sustainability aspects. And we look forward for that one, but I will just briefly touch what's sustainability. And then let us get introduced to geosynthetics and what are the various types, functions, and applications of geosynthetics. Of course, most of you have learned about geosynthetics. This is a quick recap of what are the different types of geosynthetics and what are the functions and applications. Quickly, we will review. And then among various applications, I will basically touch upon the shallow foundations. So that is the geosynthetics for shallow foundations, focusing on the results obtained from our research group. One of my PhD scholar, Dr. L.V.PRASAD, had conducted several physical model studies. So those things I quickly share with you. And then geosynthetics as a ground improvement material, to indicate that a case study of ground improvement for an embankment site using the PVDs. I will try to introduce a crispily. I will try to introduce, and then of course my core research area is of retaining wall studies, where shaking table studies and numerical model studies were conducted by some of myself and my research scholars. I will try to give, depending on the time, how it will go, and then quickly some concluding remarks. This is how I organized. I'm planning to take up to about 3:30. Dr. Manohar, how much time I can have?
Up to 4 p.m. sir.
4 p.m. 4 p.m. next session starts now. When is next session?
Maximum 2 hours, sir.
Next session, when it will start?
From
4:30, sir. Actually,
4:30.
Next session is 4:30, sir.
Okay, fine.
Before 4, it is okay, sir.
Okay, fine. So let me see. Okay, so looking into the definition of sustainability, a simple definition, a simplified definition. Okay, any development that meets the needs of the present generation, but without compromising the ability of future generations to meet their own needs. This is a simple definition. It will give a lot of inference right? Whatever the task, whatever the steps we will take, okay, it should not only meet our current requirements, but at the same time, it should not affect the future generations, their activities and their requirements. Okay, so this is a simple definition. So the sustainability can be balanced with the basic three elements like three E's, balancing three E's as defined in this Basu et al. In 2017, they have given a wide, extensive definition of sustainability of various aspects. But I quickly take these three E's concept to introduce this sustainability. So there are three E's linked, starting with the environment. What are the material we choose? What are the steps we adopt for the present execution? We should not disturb too much the environment, and we have to make it sustainable. Even future generation should not get affected. And any project, any aspect, any development, what we take, we have to see the economics of the project. And equity means a different type of applications, different class use of the things. We have to see for the growth control, etc. So these three, again, we have to interlink. Okay, interlinking all the three is achieving the sustainability. In a simple words, what we can say, what are the sustainability aspects are: one is saving the natural resources, that is ensuring the environment, retaining the environment for future, and cost effectiveness, so looking into the economics, and also improved structure performance and reduced maintenance cost. These two things we have to balance to achieve the sustainability. These are the goals, primary goals of any sustainable aspects when we are looking into any particular project. So now, having gone to the definition of sustainability, let us see the geosynthetics as a civil engineering material. So where we are now, how the material has been introduced, what is the current state. So conventionally, if you talk about materials related to civil engineering, what comes to your mind is one steel, cement, sand, aggregate, and allied elements like concrete and so on for several decades. That was the situation. And about 3, 4, 5 decades before, last few decades, the materials of soil reinforcement was introduced, and then the reinforcing material has been transformed to as a polymeric reinforcing material, which is now being called as geosynthetics. That is being extensively being used as a common civil engineering material in almost all type of civil engineering projects. That is a development. And of course, in our country, India, in the last 1-2 decades, 1 decade, we can say a significant increase in the use of geosynthetics. Many of the manufacturers have started manufacturing. Many of the developments in terms of guidelines, design codes, etc., are being.
Excuse me.
Yeah.
Have you? Your slide is not screen, sir. So it is in slide 1 or 2, 3.
Slide
number.
What is it? Is written geosynthetics is written.
Yeah, yes, sir. Main first title slide is okay. Then slide number 2, 3, 4.
Sir, the slides are not changing, sir. Actually, it is showing only the first slide till now.
Now?
Yes, sir. Yes, sir.
Now, is it not changing now?
Not changing, sir.
Oh.
Just please click in left side, sir. 1, 2, 3 is like that slide number. Then it will.
Okay, you are seeing the complete both thing. Okay.
Sir, we are able to see the left side scroll button also, sir.
Okay. Yes, thanks for pointing out this. So, better, I will share entire screen.
Yes, sir.
Okay, now is it more to content?
Yes. Now
okay.
It is content.
Okay. Yeah. So I think I will not say it again. I think these are some of the things when I was explaining about various content, and this is what I try to explain about sustainability, a definition, and 3 E's which are represented by this triangle. As I mentioned, it should be balancing between the environment, economics, and equity. A simple definition of sustainability aspects: saving of natural resources, cost and improved structure performance, and reduce maintenance costs. These are all the things should be satisfied when we are ensuring the sustainability in any project that is being undertaken. So this is what I'm explaining as a geosynthetic as a civil engineering material, as conventional civil engineering materials, right? We have steel, cement, and other materials. Of course, now geosynthetics is now being commonly used in almost all civil engineering applications. Particularly in European countries, they are extensively being used. First comes in Germany and USA, Japan, China, a lot of other places. Many developed countries, they are significantly being adopting the geosynthetics as a common civil engineering material. As I mentioned, in the last 1-2 decades, even in India, a lot of significant development in the use of geosynthetics. There are certain codes also being developed, particularly in the last 5-6 years. There are in the IRC has released several codes, and IS codes also they have released, and they are under revision also. Some selected committee members, they are looking into the international standards to bring out the IS Indian standards on that one. And even some of the design and construction manuals, they have now incorporated the geosynthetics aspects, their application aspects into these construction manuals. And of course, unless the items are being introduced in the schedule of rates, many of the government works and public projects, they would not take the particular item, even though design-wise or technical feasibility is ensured. Unless they are not introduced in the design standards and schedule of rates are available, they would not be taking. So that is also in CPWD guidelines, CPWD schedule of rates. They have introduced in the recent years. And referring to all these things, the guidelines for the use of the geosynthetic material as a civil engineering, common regular civil engineering material, we are progressing in that way. And I'm sure in the coming years, when we teach about the building materials, we should also be introducing the geosynthetics as a common building material introducing the civil engineering students. That's what the stage we have to reach, and we have to make it as a common material. So many of the universities now currently this geosynthetics are being offered as an elective course, and the lab components are being offered as elective.
If we can all be serious about what is being discussed here. And at the very outset, I always thank my students who have helped me to put together this presentation. So these are my graduate students who worked on this project and helped me to put together this presentation. So before I get into the technical details of my presentation, so I just want to mention where I am from. I'm from Chicago. This is the map of US. I hope many of you have visited US. And next time you come to US, you are more than welcome to visit my place, Chicago. And Chicago is a beautiful place. And a lot of civil infrastructure and a lot of sustainable environmental practices that you can see. And the bottom two pictures are my university picture, which is very close to downtown, where all the activity goes on, maybe at about 10 minutes walking distance. So again, I just want to give you background to what kind of research I do. I am heading these two labs, Sustainable Engineering Research Lab and Geotechnical and Geoenvironmental Engineering Lab. And a lot of my research is on geoenvironmental engineering. The first one that deals with is the environmental remediation of soils, sediments, groundwater, and stormwater. So I deal with how do you clean up contaminated soils, sediments, groundwater, and stormwater using different technologies. I also deal with waste management and landfill engineering, beneficial use of waste materials, biological degradation of the waste, landfills. So those things I also do research on. So for last several years, I've been working on life cycle assessment and sustainable and resilient engineering. This is a very broad field. I also teach a graduate level class on sustainable engineering, and the students from all engineering disciplines actually take this course. But my focus is on, developing sustainability analytics, quantifying the sustainability. And once you have that kind of framework, you can apply to any kind of engineering project. So, since I do research in geotechnical and geoenvironmental, I apply to, those systems extensively. But as you see, from today's presentation, it can be applied to, any other civil engineering systems. My master's and PhD were in geotechnical engineering, and my undergraduate is in civil engineering. So even though I teach geotechnical engineering courses and do consulting in geotechnical engineering courses, a lot of my focus is on this geoenvironmental engineering, the first and the second topic, and life cycle assessment and sustainable engineering is a emerging topic, and I've been doing a lot of work in that area. So whatever work we have done for so many years has been summarized in 4 books and many journal papers, many conference papers. If you are ever interested in knowing more details about my research, so you can go to this website and get the details. So in my research, I always say that the research is not aimed at publishing papers, but solving the real world problem. So we identify a real world problem, try to come up with a solution idea, and then we test that one in bench scale testing, large scale lab testing, and then we do the modeling and design the scale up systems. And then in the field, we go there and try to see if it works in the field scenario. If it works, then we develop the design guidelines, and design professionals can use that solution. So all our research is aimed at advancing the fundamentals, because we are in the university. So our goal is to advance the science and engineering, but ultimately to solve the real world societal problems. So in all the projects that I do, I try to consider these aspects. I do a lot of experimental research. So this is my lab, this is my equipment. So we have a lot of material testing equipment, and I do more on not only mechanical side but chemical side. So I have a geochemical testing equipment, and we can create the bench scale models to do whatever we want for our projects. So that's the things that we have. And in terms of the students, we get students from all over the world. I'm showing the pictures of the students and scholars that I had the opportunity to work with. As you see, many people enjoy working in my lab. Nobody is crying. Nobody has a serious faces. So many of them are smiling. So it's a rewarding experience to work with students and get research done. So with that brief introduction to my background, let's get to the presentation. So in my presentation, as I mentioned, this presentation is tailored based on the program theme and titles that are topics that are aimed to be covered. So I'm going to give you brief background about project. And this project involved pavement design alternatives. I'm going to mention that one, but most of the time I would say spend is on sustainability assessment. And so I'm going to apply this methodology where we look at environmental sustainability, economic sustainability, social sustainability, and we integrate all those three aspects, environmental, economic, and social, and look at holistically what is the sustainability. So I'm going to apply this framework that we developed for this example, but the takeaway would be you can apply the same framework for any other problem that you are dealing with. So I really want this presentation to be useful. So even though I am covering one payment example here, but it can be applied to any other projects. So then I will draw some conclusion and closing remarks at the end. So let's talk about a project that we were interested in working on. And this is regarding the payments. As you may or may not know, United States has 2.7 million miles of paved roads and highways. It's a pretty extensive network of highways. And they require huge amounts of different material mixtures consisting of aggregate, concrete, and asphalt. And a lot of infrastructure that we have, all these roads and highways, they were built long time ago. And recently, American Society of Civil Engineers came up with the infrastructure grades, and they found out that all this infrastructure needs to be, rebuilt because it has been aged and it's not working as efficiently as it should. So that, as you may have heard in the news, that U.S. Congress has passed a new infrastructure bill. Now, there are a lot of these projects are going to happen. Going into the future, we should not be doing the same things that we did it in the past, right? I mean, so whatever the infrastructure that we're going to build, that's going to last, 50 years, 80 years, 100, next 100 years. So we really need to be careful in terms of selecting the materials and how do we construct them. And the big picture that we need to keep in our mind while doing this infrastructure is to reduce the negative environmental, social, and economic impacts and promote the sustainable development, exactly like the focus of this course. So out of this, highways and infrastructure in general, how do we know whether we are doing something in a sustainable manner or not, right? So we really need to have a quantitative framework to assess the sustainability. So in dealing with highways, so we want to have sustainable roads and highways and sustainable payments, but how can we have that, right? That's the question that everybody is asking. Now, one of the things that whole construction industry is focusing is on recycled materials. So one of those materials is recycled aggregate. So remember, as I mentioned, we have this very large network of highways that are constructed of concrete. So if you are going to build, new roadways along the same paths, so you need to, break up the concrete and then construct again, right? So when you break up the concrete, common thing is to break it up and send it to construction demolition landfill. but that is not a sustainable way to do it. So what the focus now is to, use that, crush the concrete and then use it as an aggregate for the new pavement that you are building. And among many uses for recycled aggregate, roads using it as road base material is becoming more common. So there has been a lot of research that's done on recycled aggregate, and a lot of agencies have standard specifications. So this is not new. I mean, there has been applications of this material in real practice. So my focus is on that one, applying that one on roadway construction. So the question is, how sustainable it is. Why don't we use virgin materials rather than these recycled materials? So we did this project to assess that aspect. So there's a highway. They constructed pavement using this recycled aggregate. And we have those constructed details of the project. And then we are assessing, is that sustainable compared to, looking at these other two potential alternatives that could have been possible. So the constructed design was concrete pavement with recycled aggregate subbase. That's the, how the roadway is constructed. But then we are asking these questions. Okay, that was constructed that time. It was not long ago, a few years ago, but was it a good choice? How sustainable this is. So we wanted to look at other case. Okay, if we used virgin aggregate instead of recycled aggregate, how much is the sustainable benefit is? What are the benefits in terms of the sustainability? And then other thing that we looked at is, okay, instead of concrete pavement, if I use the asphalt pavement and I use this recycled aggregate, what difference it makes from the sustainability point of view. So I hope you understand what my project is all about. So, there is a roadway and it's constructed with concrete pavement. We're using recycled aggregate. As I mentioned before, what the recycled aggregate is basically, old concrete pavement is, taken out and then crushed, and then you create aggregate, and then you're using that aggregate for the new roadway construction. So we are assessing these three options, which one is more sustainable. So, I can say this is more sustainable, or I can say this is more sustainable, or you can say, I don't know, maybe, even the second one is sustainable. But, a lot of times what happens is if you use a recycled materials, you assume that, it is sustainable. But I have many, many case studies where I have shown that recycled materials, if they are available close to the project site, then they are sustainable. But if they are available at a long distance, that require a lot of transportation, then it's better off using, nearby virgin materials rather than recycled materials. So where they are available, where are these recycled materials available, related to the project site. So, if you have close to the site, then, it becomes sustainable. But if you have to transport them, then these environmental emissions associated with the transportation are going to be so high that it's better off using, virgin materials. So, as you know, in this time, cutting any carbon emissions is extremely important. So if you are hauling long distance, the amount of greenhouse gases that you're going to generate, that's not good compared to the benefits that you are going to get by using the recycled materials. So so the idea is which one is more sustainable, and how do we do that? So this project is, just the suburbs of Chicago. It's a highway I-90. I stands for interstate. It's a reconstruction project. It's a 14-mile stretch. They reconstructed. This is how the highway looks. So this kind of a location, if you are familiar with this, you would have if you are from the local area, you would have known exactly where it is. So then, if you have a project site here, you should know, okay, where are the raw materials and, coming from? So all the materials that are needed for this, where are they coming from? Because in sustainability assessment, we really need to know what materials we need, where are they available, how are we going to transport those to the project site. So these are going to control your sustainability. And then, as I said, again, transport distances. You need to know those from the raw material vendors to the maybe, if you are mixing concrete, someplace, or you're doing on-site, you need to know where the distances are. So the payment design alternatives, those three options, as I mentioned, payment design design procedures are very well established, and we teach our students these methods. So in this one, basically, this is the cross section of that 14-mile highway that was reconstructed. And it has the concrete pavement, as you see here, the 13-inch concrete, and then they have a 3-inch subbase asphalt, and then there's a 9 inches of this recycled subbase. I said subgrade, but it's actually subbase. And so they reuse the recycled aggregate right from the same location. And the design life of this pavement is 50 years. So this is not a subgrade recycled, it's a recycled aggregate, 9 inches. So this, as I said, this is how they reconstructed the pavement. And is this sustainable? This is the question that we are asking. And then, as compared to the other alternatives that could be possible. Here, everything is exactly the same, this cross-section, except, okay, instead of using the recycled aggregate, if I use the, subbase virgin aggregate, what would be the difference, right? So that's what, that's the difference. Sorry, this is not a subgrade, but it's a subbase. So in this case, what would have happened is if I was not going to use this recycled aggregate, then all the concrete that is removed, that had to be loaded up in trucks and sent it to landfills, and then we have to bring in virgin aggregate from wherever it is available and to the project site and use it. And even this also has a design life of 50 years. Now we thought about this third alternative. Instead of concrete pavement, can we use the asphalt pavement? So this is the asphalt pavement design you have here, and asphalt
contributed to the IRC development of the IRC code, like IRC 37, IRC 58, then IRC 115, etc., etc. So with his vast experience in the practical knowledge and academic input, we'd like to listen from Professor Reddy. So if all of you are ready, then the forum is handed over to Professor Reddy. Reddy sir, please, you can start the session. Reddy sir, you are muted.
Yeah. So good morning, my friend Mukaddas Ali and Mr. Prasad and other participants. Okay. So at the outset, let me thank
Dr. Prasad and Professor Mukaddas Ali for giving me this opportunity to present a topic which has got practical relevance, where we did some work. Okay, probably I would have, of course, delivered this in other forums, but and of course I'll be of course updating on that research projects which are have got practical application in road infrastructure. So yeah, so my topic for today's this I think FDF course is on innovative payment technologies. Sorry, I was editing this. Okay, innovative payment technologies for high volume roads. Okay, so this is my topic. So of course next I think one and a half hour or so. So I'll be telling the kind of works that what we did, and of course which has got practical relevance, also useful at this juncture, where the road infrastructure in India, of course, all of you are well aware of that. We have got a lot of prestigious and ambitious projects which have been taken up by Government of India for last more than 2 decades. So I think all of you know that the programs that are happening today are under Golden Quadrilateral, East-West, North-West, South corridor, port connectivity, Bharatmala, which is very latest, where the pending works of the Golden Quadrilateral and other things are also being integrated, where corridor approach has been considered to rectify or improve the road geometrics. Okay, and of course road infrastructure. And we are in that Bharatmala phase now. Apart from this, I think you are well aware that another very beautiful program which targets the rural areas. Okay, that is called habitations. Okay, the PMGSY program is also happening, which is continuing. Okay, good amount of money is being spent to improve the road connectivity to the rural areas. And apart from this, in the last 1.5 decade or so, we are seeing that a lot of boat transport, like shifting from other the highways to the highway and of course rail transportation to airways is happening. So with that, a lot of airport, like augmenting the existing airports, that is by brownfield concept, and also constructing new airports. Okay, that is called greenfield airports. Okay, these are also underway, and it is a long journey for us, because we have just almost began our journey to an international kind of a level, where even road infrastructure also, what we are seeing today, of course, this will be a continuous, like perennial kind of a thing, which will happen continuously for the next few decades. So where a day will come where we'll also be competent with the other countries in terms of road infrastructure, where a lot of expressways, etc., are likely to come in future. That is what we are seeing. So all these tasks, this construction are done by NHAI. This is a main organization under umbrella of Ministry of Road Transport and Highways, which is a independent autonomous body headquartered Delhi. So the responsibility of the national highways, of course, managing national highways, constructing, all these things are done by NHAI. And of course, recently also they have again created another one, National Highway Infrastructure Development, another small unit, which also takes care of some part of the road infrastructure. Apart from this, all state highways, each state has got a national highway division. So some roads of a state are also are constructed and managed by the state PW departments as well. So in all these road infrastructure, what we are seeing is, of course, not only we are building a new roads,
new, some links are being proposed, because now we are getting new links. Okay, but most of the activity which has happened till recently was earlier we had 2 lanes, so 2 lane to 4 lane, 4 to 6, 6 to 8. So this is what we have done. Okay, not like, for example, NH. People are like, where I am staying, NH6. NH6 is a old NH6 only. Of course, now numbers have been changed. Odd even kind of thing have come. Everything is same, but only thing is, like 20 years back, it was a 2-lane road here. Okay, where I am staying, Calcutta, Kharagpur. But now it was made to 4-lane in 2000, I think 2-3 like that. And in 2010 to 12, or almost 13, it has made to 6-lane. And apart from that, that is called widening and of course strengthening the existing carriageway. Apart from that, what we are seeing is, we are also, and especially I'm just talking about Kharagpur, Calcutta, which is almost 150 kilometers. So it is changed from 2-lane to 4, 4 to 6. Now what is going to happen is, slowly we are also going to have a expressway kind of system. Expressway, as all of you know, that this is the very highest quality of road infrastructure. The difference between expressway and a national highway is, the expressway has to be divided carriageway, 4-lane minimum, and you will have access control like a fence. Imagine that Kharagpur to Calcutta, like you have a fence on either side. Okay, like no human being, no vehicle. Okay, no other things can be entered. Entered or exit wherever they want. It's not so, but it can be done in a proper way, like joining, constructing some kind of a grade separated structures. Okay, or any other facility which will merge the traffic, similarly which will allow the traffic to diverge. So it's kind of complete control. Okay, so what we are seeing is, this road, I think later on the other day, so this is going to be an expressway. Okay, like for example, if I start from Kharagpur to Calcutta, so like 150 kilometers, so I should be able to complete. If I go with 100 kilometers, I should reach it 1.5 hours. That's all. Simple as that. So this is what the things are happening. And similarly, several such roads, okay, important networks will be converted into expressways in future. Similarly, of course, a huge amount of traffic is also being generated on this. And other important area which is coming up, which is already just started, is payment asset management, because these are the national assets. Okay, we have created so many assets. Okay, and these assets have to be managed. You know, a road is a of course, we have very wrong illusion that if a rain comes, of course, rain means, okay, normal rain comes also, payments getting washed away, and everybody maybe accept that, okay, because of rain, payment has gone. But of course, if the floods are like very severe, yeah, payments can get damaged. But for normal rains, it should not happen. Anyway, that is a different thing. So these payments are going to deteriorate even otherwise also. So you need to manage these assets, because if you want to improve even 1 kilometer of road length, okay, after construction, you have to incur lakhs and crores of rupees. So how well you are going to manage these assets? So for that, a system has to be developed. So life cycle cost analysis has to be made. Which payment, how is going to deteriorate? We don't have such models. So now a lot of emphasis has been given by Government of India to manage these assets. So for information, now Government of India is collecting, okay, the data, road failure data, okay, that is distress failures, distress condition or payment condition, more specifically for condition of the existing payments, once in 6 months. So I show that equipment also. It is called Network Survey Vehicle, NSV. So every 6 months, okay, all the national highways of the country, the data is being collected to know what kind of failures, and they have some kind of mechanism. Like, of course, the models are not there, but anyway, they have got some kind of a way which you can say that, okay, this payment is in good condition, this is not, this is in very bad condition, poor condition, moderate. This kind of qualitative assessment is given. Then improvements are being planned. So every 6 months, you know, the data has been collected. So such a importance is been given to the asset management. Okay. Finally, the target of entire this system is to have a safer roads. So this has become alarming situation because accidents are not decreasing; it is other side increasing. So it's a very complex kind of a thing. It's not like that easy to uh, make a safer roads. Very complex. Appears to be simpler, but it's very difficult because you are going to have to control a millions of drivers and millions of vehicles, okay, on a road, okay, and even 100 times more than that of a pedestrians who are also using this. So each has got individual characteristics, okay. So very difficult to address the driver characteristics of an individual, vehicle characteristics, and the human characteristics. So unless we address all of them, okay, in a holistic way, it's very difficult to achieve safer roads. So long way to go, and government of India is also spending good amount of money on safer roads. So these are the emerging areas which you will be seeing, okay, in future. So as I told that, what is the scenario now? Because of this economic growth, very high traffic volumes and very high axle loads, we don't have control. And recently government of India has increased the axle load, legally permitted axle loads. Okay, earlier like this has got a 6 ton, and the dual wheel, this is dual tandem. Okay, this has got around 10.2, okay, like 4 wheels, but it has been increased slightly. But of course, even then, the permissible, the legal loads which are carried by the truck drivers and the tire pressures are very high. Okay, and other thing is the fast depletion of natural resources. Of course, we are very much seeing that even the rains which are happening in the recent times in some of the places, erratic way of behavior. I mean, the rainfall, the rise in temperature, all because of the natural resources which are depleting very fast. Even in highway infrastructure also, what we are constructing today and what is required in future, if you consider that, the natural resources will become very costly in future. So this is our problems that we have. And in order to, of course, to have all these kind of issues, what are the ways in which we can address these things? Like especially what I'm going to talk about is the how we can decrease the use of the natural resources. Okay, so one of the ways of decreasing the natural resources is, I consider it as in two forms. One is, can I reduce the thickness of payments? This is what everybody will ask. Okay, today concrete payments are like 300 mm, 280 mm. So can I make it as 230, 240? Is it possible? That is one. The second one, even if it is not possible, okay, what are the ways in which I do not use the natural resources, like natural aggregates, virgin aggregates I don't use. I don't use the sand which is there, which is becoming very demanding. So I don't use them. But where I'm going to get this, I should look for some other alternatives. What are the alternatives that we have? We have a lot of industrial byproducts.
Then work experience, if you come to the work experience, presently she is working in Chennai as an assistant manager, and I will describe some responsibility of Nadia as a assistant manager, collecting DPR on daily basis and reporting it to higher management daily. That means mainly she is a project manager, monitoring the progress of the project and noting the obstructions hampering the progress, and coordinating with RO, SCM and project site for source approval of track and long lead material, maintaining subcontracts strip charts as per the deployment. Like that, she is going to have connection in between the site and with the design engineers, as a project engineer, and preparation and circulation of DPR and updating MLite in the projects. Like that, she is having some responsibilities, and her project was IRC design of flexible pavement played on different soil subgrades at UG level. And if you take her extracurricular activities, she is served as a coordinator by conducting a quiz competition for Sudha 2K18, a 2-day national level technical fest. And if you come to the academic achievements, Pratibha Award. She achieved a Pratibha Award for excellence in diploma examination in 2016 and achieved 8th rank in ECESET examination, secured second prize in quiz competition organized on the occasion of Engineers Day celebrations. So indirectly, I can say she is a more talented person, and we are very much thankful to her to joining with us, and it is very great day because we are getting a practical experienced person in this FDP, and I am welcoming you, madam.
Hello, sir. Good evening.
Miss Nadia, madam. Good evening. You please can you switch on your presentation and video for because we are taking the recording, madam, so that
Yes.
throughout the recording we will have your presentation and your screen also. If you have any technical problem, then you switch off your video, only you present it also, no problem. So you check your presentation, madam, if it is okay.
Yes.
Yes, madam. Yes, madam, your video is clear. Now you check
Yes.
with your presentation.
Hello, everyone. Good evening. I'm Nadia, working as an assistant manager in Tata Projects Limited. I have just 2 years experience. Based on my knowledge, I would like to explain something I came to learn in these 2 years. And I'm very glad, sir, for getting this opportunity. Thank you, sir, Prasad, sir.
Thank you, madam. Please carry on.
Yeah, sir. And today I would like to explain about the innovations in formwork and mainly the importance and applications of aluminum formwork. I'm sharing my screen.
Yes, madam, it is coming. You go to the presentation mode so that it will come as a full screen. Yes.
Yes. As I said, the title is Innovations in Formwork and the Importance of Aluminum Formwork in Present Days.
Madam,
Majorly for,
are you completely sharing full? You are sharing entire screen, or you are sharing a window?
Okay, sorry, sir, sorry.
Please share your entire screen so that if you keep in presentation mode, then only this presentation will come. Please.